欢迎贵宾们莅临2022 Flexing Future 数位分身工业元宇宙产业高峰论坛。活动将在5分钟后开始，请贵宾们可以即刻就座了。 各位来宾，大家好，活动即将开始，请大家赶快入座，谢谢。各位来宾。
Ladies and gentlemen, distinguished guests, dear trainees, dear instructors, good morning. Welcome to FlexSim 2020 Summit. I'm your MC, Julie. I don't know whether you are like me, that it's been a while since you take a walk outside of your home. We have canceled a lot of physical events, and a lot of events have become virtualized. But now the pandemic is almost over. Now we have an opportunity to get together. However, we still have to put our mask on at all times, and also to protect the intellectual property rights of various companies. We should not take pictures or make audio or video recordings. You're welcome to engage in exchanges with our speakers today. Now, without further ado, we'll start today's event. Our themes include digital twins and metaverse. Many of you may not have a clear idea about what they are. Let me briefly introduce them. In the course of production, the use of digital twins can make the production process simpler, and also we can identify problems, correct problems early on, and also we can prevent the disruption of production so that the enterprises can conduct better analysis and prediction of the future challenges. And also digital models can cover the entire facility system. FlexSim is the best digital twin software. Through FlexSim, we can set up a factory process, and then we can try different scenarios at no cost and optimize our production process so that we can enhance our competitiveness and business opportunities. In our event, many speakers will share their experience with us regarding FlexSim. Our program will be concluded at 4:30 p.m. If you need any assistance, feel free to contact our staff in the menu. They all wear a red badge. And also during the break, during the exhibition area, there are various demonstrations of the outcomes of the use of FlexSim. You're welcome to take a look. And also, we are going to rate the top 3 best products in the competition. And also, if you are interested in recruiting the best performing students, you're welcome to exchange contact information with the students. I hope that through today's event, you'll be able to find out what you want. And for all the students, I think you have received the materials regarding the different stages of the challenges that you should complete. And after you successfully complete the challenges, you'll be able to receive our gifts. And for the participants, we also will draw a lot to see who will win our prize today. And also, NVIDIA has provided a gift which is valued at 47,000 NT dollars. So make sure that you put your lot to the box. Now we are going to take a group photo. we are going to take a group photo. Our people, please should provide assistance to people taking the group photo. Metaverse, great. Metaverse, great. Thank you. Please don't throw away your signs. We are going to use them later for other purposes. Now let's welcome the. Let's look at the welcoming video clip.
Organizing this event. I also want to thank you, our users, for your continued support of our simulation modeling and analysis software. The COVID-19 pandemic and recent armed conflicts have created disorder and uncertainty in factories and supply chains around the world. We believe that simulation modeling and digital twin solutions are the key to unlocking stronger, more resilient operations to help usher in a brighter future for all. The presentations you will see today will show examples of how this can be done using FlexSim, and I hope you will be inspired to analyze and transform your own processes. Thank you for attending FlexSim Future 2022 and enjoy the rest of the forum.
FlexSim 2022 brings more functionality for AI and machine learning. The new reinforcement learning tool allows you to use a FlexSim model as an environment for training and evaluating reinforcement learning algorithms. This tool provides features needed for a reinforcement learning algorithm to communicate with FlexSim. You'll find a simple yet powerful interface for both training the algorithm and using the AI trained model in a real production environment. The reinforcement learning tool is also flexible enough to be able to interface with any machine learning environment you'd like. You will set up a pre-built algorithm that will learn to minimize changeover times as it figures out which item to pull next. Once you've finished with the example, you'll have a trained reinforcement learning model, and you'll be able to evaluate the AI's decisions in your simulation environment and even use the trained AI to make predictions. FlexSim's free GIS module is a powerful new tool for modeling supply chains, interlogistics, and any other transportation uses where travel time and distance are a factor. The module is centered around the new map object, which can be dragged from the library right into the 3D view. Once you select the map by left-clicking with the mouse, you can click and drag to pan the map's position and use the mouse wheel to zoom into a particular location. The other main objects are points, which can be dragged from the library and onto the map. Points can use one of our pre-installed shapes to enhance the visuals on the map, or you can change it to any custom 3D shape in the points properties. Task executors can be connected to any of these points to visualize the route, and we also have some new pre-installed shapes you can use for these vehicles. The GIS module can handle 3 types of routes. The 2 most common will be driving roads and flight path. The driving roads route type downloads the roads information from the routing server, which is already pre-configured for your convenience. Your trucks or other road vehicles will take the shortest route to get between the 2 connected points. The flight path is used to connect 2 airports, and you can adjust the air route calculations, including average speed and costing, in the GIS Navigator properties. The mass flow conveyor is an essential addition to FlexSim's standard object library. This conveyor object can simulate the flow of high volumes of units. It will be useful in various modeling applications, including food and bulk goods manufacturing, bottling and packaging, and in other high-speed or high-volume manufacturing systems. The mass flow conveyor is unique in that it can model a conveying system transporting thousands of units with high accuracy, but it can do so without breaking the bank on computing requirements. How is it so efficient? The mass flow conveyor uses more of a fluid-based modeling approach rather than simulating each discrete unit. It would take a massive amount of resources to simulate thousands of bottles, cartons, or other small pieces individually. Instead, the mass flow conveyor calculates the unit density and maximum possible flow rate for the units traveling the conveyor, then tracks density changes resulting from other system changes. It's fast, it's easy to use, and the result is beautiful. FlexSim's rendering engine draws individual units based on the density at a given point, so you'll still get to see your production system in vivid detail. Check out the mass flow conveyor today. You can try it out free by going to www.flexsim.com.
好，那我们现在介绍。
Now, let's introduce our guests today. The first is President Daniel Chen, CEO of Pitotech, and Mr. Sheng-guang Liu from Innolux, Chief Director, and also Manager Yizhang Cai of CPC, and also Hsu Chien-bo, Technical Manager of WNC, Daniel Chen, CEO of Pitotech Company, and also Wen-bin Liu, CTO of SAA, Manager Zhengbang Chen of Symtek Inc., Director Jiazhuo Huang of Symtek Inc. First, let's welcome Mr. Yizhang Cai of CPC to give us an opening remark. CPC has been providing channels for learning to enterprises and providing all kinds of services to enterprises. Let's welcome Mr. Cai. Thank you. We have plenty of the materials for our discussion, so I'm instructed to follow my script. President Lin Chen of Zhanghua Computer Association and CEO Jian of Pitotech, and also Vice President Chen of Symtek, and also distinguished guests, ladies and gentlemen. We have many guests in today's event. In addition to our activities in the venue, we also have we are also broadcasting the event overseas. On behalf of China Productivity Center, I'd like to express my sincere gratitude to you, and I'd like to welcome you to this event. I also am grateful to Symtek Inc. for its support of this event. Through today's forum, it is my sincere sincere hope that we will be able to popularize or disseminate information about the technologies. In recent years, due to the impact of the pandemic, as well as the war in Ukraine, and also the trade war between U.S. and China, our industries are facing great challenges. However, the enterprises are still working very hard to improve their efficiency and reduce their costs while providing better services. In the future, smart manufacturing technologies are very important drivers for facilitating the improvement of enterprises. Today, we are going to learn a lot in that front. The ROC government has been working very hard in pushing forward the development of smart manufacturing by launching various policies. The CPC is playing an important role by conducting activities such as smart manufacturing training. We hope that we'll be able to expand the capacity that we have built to overseas partners. And that's why we are conducting the event today. Regarding our friends participating overseas, in 2019, we have applied to the APO for establishing a Smart Manufacturing Center of Excellence. And today, we are providing a linkage opportunity to our partners overseas on the front of smart manufacturing. By working together, we'll be able to usher in a better era tomorrow. Thank you very much.
Thank you, Manager Cai, for the opening. Next, we'd like to invite Chairman Chen from the Changhua County Computer Association to give an opening remark. The Changhua County Computer Association is a platform that provides our friends in the middle and the southern part of Taiwan to engage in further training regarding computer skills as well as programming skills. Let's now welcome Chairman Chen. Thank you. Distinguished ladies and gentlemen, it feels as if I'm in a metaverse today, because when we talk about the metaverse, everyone has a role to play. In the past, or I shouldn't say in the past, but rather, I am still the Changhua County Computer Association chairperson, and before I was the chairman of the Pitotech company, actually. So when the metaverse was raised, the first time we heard about it was perhaps when Zuckerberg wanted to change Facebook to Metaverse. And have you thought of the reason behind this? My personal opinion was maybe Zuckerberg wants to be God. And the reason I say so is because he is trying to create a whole new world, like what God is doing. We do not know who created us, but those or he who created us definitely knows and is looking over the development of this world that was created. So if Zuckerberg's goal is to create a new world called the Metaverse, then we need to know what is the role that we can play in this new world. I like to say that we are all creators, and we are all able to create our own universe. A general manager, a director, an employee in the workplace is actually able to create his or her own universe. And the universes we create would interact with each other and create new sparks. So from my perspective, Mr. Zuckerberg actually wants to be a godlike entity. And when we are engaged in the world that he creates, when we carry out simulations, it seems as if we are also playing a role in that world. For example, in the past, when we built factories, we had to start from scratch. But now we can actually build a model in the computer first. So what I would like to touch on is it doesn't matter what position you're in. You can be the president, the director, a technician. But with the right skills and the right technology, you would actually be able to play a better role in this whole new universe. With the advent of more prevalent AI technology, combined with the current simulation techniques, I'm sure our production lines will be more efficient in the future. BMW has used digital twins to compare the efficiencies of their factories, and they've discovered that digital twins can actually up the efficiency by about 30%. At our workplace, we definitely all have bosses to answer to, and when you get a mission, if you're able to do better, if you're able to create a better model and to create a, for example, production line quicker, then not only would you be able to have a better understanding of the entire manufacturing process, but it also make it quicker for you to troubleshoot and to solve challenges or obstacles that the company may face. Therefore, once again, it is truly a pleasure to see so many friends here today, and we're all in this metaverse together. So I wish you all prosperity and health. Thank you very much. Thank you, Chairman Chen. Finally, we'd like to invite representatives of SymWeb Inc. SymWeb was established in 1946 and has assisted in the technology transition stages. Let's now welcome Vice President Jiaming Chen to give an opening remark. Distinguished guests, ladies and gentlemen, welcome to the forum today. It's my pleasure to see so many familiar faces, and it is also our honor to be able to invite the well-known and distinguished speakers to this forum. I'd like to take this opportunity to thank all the parties that assisted us in organizing the forum. First off, the China Productivity Center. I'd like to give my personal thanks to Manager Tsai for helping us secure the venue as well as provide the necessary support to create this forum. We believe this is a win-win situation, and with the restart of this forum, I believe this is a new starting point for everyone. This forum has already been put on hiatus for 2 years because of the pandemic. But now that it's restarted, I believe our goal is still to increase the competitiveness of one's own company. I believe that by sharing the technology, we're actually able to learn from each other. If you look at the martial arts history, then you would know that you need to fight with others in order to improve your skills. If you simply stay at home, then your skills will not improve. But by interacting with others, you would actually be able to learn new techniques, learn new skills, and improve your prowess. So I think this is the key goal for this forum. Through the interactions and exchanges in this industry, we will be able to introduce to the world a new stage and cultivate new talents so that they can continue to push forward. We also especially invite students to join the forum, as this will serve as a suitable platform for them to learn what is needed in the current work environment and to allow them to make the linkage between the academia and the industry. And with this effort, we will be able to retain the best talents in Taiwan. So this is one of the reasons that we held this forum, and I do hope you all get fruitful results from the day. Thank you very much. Thank you, President Chen. I'd like to thank all the three distinct guests for the opening remark, and we'll be beginning the forum. The world has been hit severely by the pandemic and by the war in Ukraine, as well as many other negative factors. And in a turbulent world, the responsiveness of a company is especially important. How should a company react to an ever-changing world? It is our pleasure to invite CEO Mr. Daniel Chen of Pitotech to share with us how to use digital twins to create resilience in the metaverse. Mr. Daniel Chen. Distinguished guests, good morning. I hope I can be heard at the back of the room. I'll be touching on three areas today. The first would be the digital twin. The second is the industrial metaverse. I will be focusing especially on the industrial metaverse because ever since this concept was raised, it's actually closely linked to the social community and the market. Mr. Zuckerberg wants to create a whole new biosystem, and maybe he has even have ideas for a metaverse currency. Currently, from the way we look at it, we believe an industrial metaverse would likely be created out of these discussions. And also I'll be talking about resilience. It is an important quality for companies. And resilience actually comes from connections. We can create a metaverse or create a universe, but if you stand alone, then it's not sustainable. Companies need to interact with each other. The numerous business strategies are all ways for companies to survive and to survive together. And if companies do well, then the employees get paid better. So it's a win-win situation that we're trying to create. So without further ado, let's move on with digital twin. This is actually not a new concept. If you look at the early history of war, the Sun Tzu War Manual actually talks about a simulation, about creating a twin. And in the current world, the digital twin is similar to what we call simulations. And in ancient history, the art of war actually talks about how you can how you actually tend to confuse the enemy by using real moves and false moves. And basically, the point is to confuse the enemy so that they can't distinguish between the real one and the false one. But it's basically creating a twin of the actual maneuver. And that's basically what digital twin is about. It's a creation or a simulation of the actual process. But of course, the evolution of digital twin is not just simply something that happened overnight, but rather it went through a process. As you can see on this slide, we talked about digital twin very early in the 1990s. And at that time, we talked about a digital model. For example, a digital model in CAD or in a simulation. Some also use Squid or other platforms to create a model. It doesn't necessarily have to be a 3D model, but in the 1.0 and 2.0 stage, as long as you can create a virtual representation, then that can be considered a digital twin in the early days. And we sometimes call it a digital shadow. But by digital shadow, we're actually moving into 2.0 and 3.0, thanks to the advent of new technology, we're able to not just create a digital representation, but we're actually able to link the digital representation with a data flow, and therefore data would flow between the physical object and the digital representation, and that is what we call a digital shadow. Now, many companies actually aren't even able to create a digital shadow because they have a bottleneck in terms of the simulation technology. For companies like us, who started from scratch, we actually had to learn the basics first. And just ask me, and I can actually share my experience with you.
Currently, we have seen complex systems and innovation technologies, and also the industries getting more and more complex. Even mobile phones are very different from the past. And also in the past, our PC CPU was 386 or 486. Now the CPUs are much more powerful. So a lot of things are different now. Now we need data. Whoever controls data can control the clients. So the data is the key. Now we have media such as Digital Time. They have a good group of the clients. They can conduct different events, and they operate different business models. Now in the era of Industry 4.0, now we are also in the era of Digital 4.0. The key is not just about the offline. We need to pay attention to real-time needs. So Digital Shadow 3.0 is not yet good enough to qualify as Digital Twin 4.0. At this time, IoT plays a very important role. In the beginning, without the support of digital or AI, IoT is not Internet of Things, but it will become I only talk. You need to have data. You need to be supported by data. So this is the path of evolution of digital twin. Today, I'm going to provide you with some bonuses. I'm not just talking about FlexSim or application of FlexSim. I'm not going to just provide you with an overview of a digital twin. But if from a system programming or system level perspective, our many speakers will flash their views on FlexSim application. That's the system level sharing, and it's a whole factory application. But for system programs, when you are formulating your company-wide or corporate strategies or system strategies, this is a very important stage. You need to come up with your strategy. So you need to have a strategy for your production lines, and also based on my supply chain, how I should properly arrange the production lines. And I can use AGV in the points of production that require a lot of wait time. So we need to perform a lot of simulation to create digital twins. So the consideration is entirely process-oriented. And of course, you can think about the PLC of each machine tools. But you do not simulate every step because that will be too time-consuming. Many business owners talk about digital twins, and I don't know if you understand that there are different levels of digital twins. You have different knives or tools to perform different purposes or to achieve different purposes. A surgical knife is used for surgeries, not for cutting fruit. So there are different levels of digital twins. You cannot just find one digital twin solution for all the issues. that you like to resolve. So there are different levels of digital twins that are appropriate for you. So on the system level, you need to formulate your spec and our strategy, and then you need to anticipate your production capacity, which is the most important aspect in your planning, because without adequate production capacity, you cannot produce the products that you desire. And also, a lot of people, a lot of companies are booking or reserving the production capacity of their vendors. So production capacities are very important. So on the system level, flexing plays a role as such on the system level. Another level is virtual commissioning. Why do we need virtual commissioning? Because when flexing is used to perform simulation on the system level, then you get an idea about the tools that are used in the production line and also the strategies for assigning AGVs. So after you have come up with the strategies and you have made all kinds of predictions and you have created the layouts, when you try to communicate that this layout is the most optimized, is the best, after you have done all the optimization work, but when you communicate information as to how to execute it, how to do it, so that's the next level I'm talking about. That's virtual commissioning. Virtual commissioning of the digital twins is conducted under very different considerations for automated warehousing. The CI image achieved in 5 seconds. How do you achieve that? The business owner just wants results, but for the employees, they need to think about how to actually work out a solution to meet the expectation of the business owners. So this is the role played by, assumed the role of virtual commissioning. Different machine tools are subject to different restrictions, the different dimension restrictions, and also the collaboration between robots and different production lines, whether the robotic arms can operate smoothly. And also during the pandemic era, you cannot access certain facilities. And this is a problem facing systems integrators, because they need to conduct on-site inspection and operation to identify the real problems. If the robots are damaged, a lot of money will be lost. So virtual commissioning is very important. And also the optimization of PLC software is very important, so that you can do this commissioning remotely, and you don't need to do that on site. So this is a different technology. So from system, we talk about system and station level, line level, station level, and machine level. On the machine level, I'm talking about robots. And you need to consider the collaboration between robots. There are hundreds of types of robots. Robots have their individual differences. For some robotic arms, they cannot move at a larger angle. And also the collaboration may be time-consuming. It's not as easy as you think. When you change your production process, you need to make the collaboration adjustment by spending at least 1 month in making the adjustment. And also you need to also consider the different jigs and fixtures that are used. And also different products may involve different parts. So when you switch the production line, when you change the production lines, you need to spend at least 3 weeks in making the adjustment to the robots. So if we can introduce digital twins, and then we can perform simulation in different scenarios. So after the simulation, all you need to do is to spend 1 to 2 hours on site to complete all the collaboration adjustment. So from the top three levels, you can see that they pertain to production and manufacturing. And the two levels at the bottom, such including physical level exploration, and also material level. The digital twins for these two levels are related to research and development. Digital twin has many aspects. We do not just talk about system level or manufacturing level only. On the R&D front, you also may run into issues such as machine tools for electrical plating machines. Sometimes the results are not even, and then you need to consider are not uniform, and you need to consider the reason why there is such a problem. Later, I'm going to talk about corporate resilience. ESG is very important as well. So in terms of physical simulation, we have dedicated products, and we have many customers for such products, such as TSMC, and also on the material level, digital twins can be used. Companies like Gogoro or Tesla, the focus of Tesla's products is batteries, but sometimes you cannot get the parameters. So what do you do if the client refuses to provide you with the parameters? Then you may have an issue. But in our time and at this time, there are different opportunities. Information is really key. So we need to apply digital twin to work on the materials level. And also, we can apply the concept of digital twin to PLM. And there are also, PLM also consists of different levels, including the system level, from design, planning, and engineering. But ultimately, you need to combine AI with big data. So for digital twin, if it's simulation driven, you may run into speed related issues. And also, you may need AI to resolve certain issues. For example, you may have different assignment or dispatching rules. I know that many companies relied manual considerations. And this is where AI applies. At first, you can use AI to replace decision-making by people. Because there are many steps, you cannot always rely on people to make decisions. But what kind of efficacy or benefits does digital twin bring? You can have more process flexibility, and also you can reduce your risk. And also, while I perform research and development, I can work on the process capability. So all the issues can be resolved very quickly. So a lot of maybe 80% of the issues can be resolved very quickly, with remaining 20% of the issues to be resolved with more time. In the past, we used a try and error approach, and that's very time consuming. And sometimes you don't know why this problem happened, and you need to conduct a lot of trial and tests. And sometimes you don't even know why a particular issue is resolved. But after you have resolved an issue, you have spent a lot of time. If you want to engage in production in Singapore, how can you conduct try and error? You don't know, you cannot try anything. And so you are supposed to launch the production maybe in a few months, but you cannot go to the location to conduct all kinds of trials. By digital twin, I'm not talking about just a system level. We can use digital twin to gain an insight of different physical and other process-related phenomena, such as for companies such as Innolux or AUO. if they use digital twin, they can simulate the behavior of optics or light. And for systems operators, they need to reduce their default risk, because oftentimes when they enter into a contract, they do so with great risks, and sometimes they may lose money due to the penalties under the contracts.
And if you look at the final two, we have predictive decision. When people talk about AI, we often say it's the main purpose of AI. That is, we want to use AIs to carry out predictive decisions, to know when we should carry out maintenances. But currently, in terms of maintenances, they're actually prescriptive decisions and not predictive. That is, it tells us what to do and not just alarm us of an incident. There's a difference here. Just providing alarm, or actually being able to provide not just alarm but also the prescription. And finally, the other benefit would be to handle uncertainties and increase resilience. So I would now like to talk about the synergy that can be created. If we look at the metaverse once again, the digital twin is one of the core building blocks or the core concepts in the metaverse. Other than increasing the quality of the overall manufacturing process, one of the key concepts in metaverse is to allow the model to be shared over the internet or over the web. By using VR, for example, people in different countries can discuss the same model, and an industrial metaverse would even change the business model. For example, an engine manufacturer used to create revenue by selling engines, but now it may actually employ a different business model and decide to rent out the engines instead, turning the manufacturing business into a rental business, and then providing additional services as well as data collection services. The digital twin also has the benefit of reducing management cost and building a hybrid workplace. Digital twins can collect the knowledge and know-how generated in the workplace and serve as a training material. And in hybrid workplaces with digital twins, employees can actually choose to work at home or in the office. In an engineering metaverse, as I've mentioned, digital twins is not just one element. There are actually many components to it. For example, the 5G connections, the IoT, 3D simulations, big data, AI, and cloud or edge computing are all components in the digital twin concept. And these combined would drive the metaverse. What AI can also do is to create a paradigm shift. When we talk about AI, it's actually here to start a transition, a transformation. By using AI, for example, if we look at this stage, that's a traditional simulation. If you turn this into an AI model, it will actually be able to do many more different types of things. Not only can it automatically collect data and analyze data, but by using AI-backed simulation, you will be able to create clean data. In the data business, people are often burdened by cleaning the data, and oftentimes 80% of the time is spent on cleaning the data. But if you incorporate AI, then the simulation will be able to generate clean data directly, and this would actually speed up the process 100-folds or even 1,000-folds. Another aspect of the digital twin is to validate the AI's result. For example, oftentimes we don't have a test site for AI, and a digital twin will actually be a very suitable environment to do so. That is what we call a metaverse augmented digital twin. From this slide, you could be able to see the digital twins examples that I've put at the upper part. This could include the airflow model, the robotic arm model, or even the turbine model. And these would actually serve its purpose in an engineering metaverse. But through a digital twin, you would actually be able to share these digital models. And this combined together would form one of the pillars of the metaverse. Finally, the last block I'd like to touch on would be resilience. So what do I mean by resilience? My definition is the ability to react quickly and to respond quickly to negative impacts in the market. Another concept is anti-fragile and immunity and recovery. The concept that I would like to promote here is not only does the company need to predict future comings, but it also needs to react quickly and even have immunity. If you have immunity, then these challenges would not take you down that easily. If we look at the pandemic, for example, if you have immunity, then even if you come into contact with the virus, you would not fall sick. So in the same vein, I was talking about how digital twins actually help companies build resilience. One of the keys building blocks here will be to prepare or to prepare beforehand. In creating resilience for companies, we need to prepare the company not just to face the pandemic, but for example, the Sino-US war or the war in Ukraine are all factors that a company must tackle. If oil goes up to $150 per barrel, then how would this affect your company? The company needs to be well prepared for all these possible market shocks and factors. So the engineering metaverse, it's actually not just a game. If you look at the EU, for example, they've already announced that they're going to levy a carbon tax. And if you are unable to deal with this, then you're basically shunned out of the market. If you look at the Apple supply chain, for example, if you cannot meet the requirements that Apple has set, then you don't even have the ticket to participate in the supply chain. So for an engineering metaverse, we're not just talking about a simple game, but rather this is, as I've mentioned, in the art of war, it's basically a stage that requires a long-term strategies and a warfare mentality. If we look at the black swan, the carbon neutrality, we often talk about this as greenwashing, or some companies would actually be greenwashing that they are simply purchasing these carbon rights and actually greenwashing their products. That is, for example, if you use carbon capture to try to offset the carbon that was created, then it's not really actually carbon neutral. The point should actually be to decrease carbon emissions and not just simply to purchase carbon rights to offset the carbon that was created. We like to talk about planting trees for every unit of cost that the company put in, but sometimes this would tend more towards what we call greenwashing. The point should always be to reduce carbon emissions and not just simply to purchase carbon rights. If we look at the current workplace, we need to take checks and scans if you have any symptoms of the COVID-19. And the company also needs to be prepared if, say, 1/3 of the workforce is unable to come to the office. Of course, if we look at more traditional situations, if there's a fire at the company, at the workplace, then what can the company do? How should the company react? These are all part of the company's resilience and ability to react quickly to these shocks. This is actually a iron forge. And of course, as you all know, the steel industry requires a lot of energy. The forging process requires heavy use of electricity and heat. And how to reduce the energy use in this process is actually what this company is working on. They use new technology and IT to optimize the energy usage in the entire forging process. And they actually calculate the amount of energy used and how reducing the energy used would actually translate into a decrease in carbon emissions. And as we now have a price for carbon emissions, this actually tells the company how much it is saving, and it also serves as a good concept to communicate with clients to show that the company cares. So this is not just greenwashing, but actually actual steps taken to make a difference. And finally, we have to be dynamic and to speed up the reactions. If we look at the cases in the pandemic, the lockdowns actually caused a lot of companies to suffer and to desperately seek new ways to survive in the market. The supermarkets, for example, used to require people to come to the local stores to purchase daily groceries. And these wholesalers that sold to supermarkets, they were actually hit significantly by the pandemic. So they actually changed the business model from a B2B to a B2C, actually used the home deliveries to make a difference. And the pandemic actually caused their revenues to grow sixfold. This case can also be seen in the airline industry. When the pandemic hit, people ceased to travel, and a lot of passenger flights had to be cancelled. The airlines were, of course, hit severely as all the planes were grounded. But then some companies decided to shift and move into freight transportation. They converted the passenger flights into freight planes. And with the need for more logistics and online commerce, they actually were able to create a whole new market and increase the revenue significantly. So that is what I mean by being dynamic. Another way is to create new business. We like to talk about shortening the supply chain. If we look at the store deployment strategies nowadays, a lot of the stores now have their own inventory. We used to think about deployment as having a large warehouse and have the warehouse connect to these different storefronts. But if you look at, for example, Momo is a local online commerce platform, and they've actually been doing quite nice during the pandemic. And the reason was they actually employed a different warehousing strategy. Instead of having a central warehouse like some of the major players in the market, they actually had smaller and more dispersed warehouses, and this actually allowed them to move the goods faster and provide better service to the customers. Another point is to reduce redundancy. No one wants to be considered redundant in the workplace. So why do we want to see redundancy at the production lines? This is always an issue at the workplace.
So we need to achieve cost up, not cost down. When you introduce digital twins, it's very important to bear in mind for IE. Sometimes people think about how much labor cost we want to reduce. It's not something that we should think about. You need to create value. Otherwise, your projects are doomed to fail. For IE, sometimes for particular industry or companies, you may think about how many people will be laid off, and you will face a lot of resistance. So for digital twin or automation, if you want to push forward such projects, you need to create value. You do not consider laying off people or reducing labor cost. And also for risks and inventory or warehousing, you can conduct all kinds of assessment using digital twins. Finally, when it comes to corporate resilience, you need to keep learning. And during the pandemic, I can give you an example. Airbnb cannot operate smoothly. Otherwise, it has to transform itself into the business of a real estate agency or real estate intermediary. I'm surprised that maybe in the past year, Airbnb's business was booming, and for real estate agents, their business was booming during the pandemic era. And Mitsukoshi department store is another example, and they can use AI plus digital data or big data to improve the customer service. And also Regent Hotel in Taiwan is another example. They have conducted interdepartmental learning, and by creating different standard operating procedures. And some for their existing manpower, which becomes available due to the pandemic, such manpower may be used for delivery services. So these are the three very important points I'd like to share with you. For companies, you need to establish your resilience by continuous learning. Thank you very much. Thank you, Mr. Jian. Now the next speaker is the CTO of Symtek Automation Asia. It's Mr. Wen-bin Lu. The company has created all kinds of equipment, and is the first company in Taiwan that has created warehousing facilities for wafer foundry operators. And Mr. Lu has indicated that it has successfully used FlexSim for assessment as to how much benefits can be achieved. Let's welcome Mr. Lu for sharing with us how the company has created industrial metaverse using FlexSim. Mr. Jian, distinguished guests, good morning. Now, I'd like to start my presentation. My topic has a few key points. I'm going to talk about the time spent by my company, SAA, in its development in the industry, and we have focused greatly on digital twin and how we can create a metaverse for the PCB logistics service. Now, first, let me introduce my company, SAA. Let me talk about the industry it's in, the services that it provides. SAA was established in 1999, and it has been established for over 2 decades. In the beginning, our focus was on PCBs. After our continuous efforts, now gradually we are focusing on the upstream and midstream and downstream areas of the semiconductor industry. We all know that Taiwan has played a very important role in the semiconductor industry in the world. So we have transformed ourselves from the focus of equipment or hardware to SI and software as well. In terms of our presence, our base is in China and Taiwan, and we have different offices in different parts of the world. If you are familiar with the PCB industry, you will understand that Asia is a global stronghold of PCB, and Taiwan plays even more important because the products sold manufactured in Taiwan are sold for high-end applications, and also we also have facilities in Europe and the U.S. and they may be local agents that provide services. In terms of our deployment of our footprint, you can see that our company covers IC carriers and also IC packaging and testing and wafer manufacturing. In the past, for companies like UMC or TSMC or other semiconductor manufacturers, they use primarily Japanese tool vendors' products. In the past few years, my company is very honored to become a part of the suppliers of these heavyweight wafer foundry operators by creating our warehousing solutions. We can make good use of the real estate available in the facilities so that the logistic operation of these companies can be more effective and efficient. We do not just need a micro warehouse. And also between different stations and different areas, there may be transport requirement using tracks, and also automated facilities moving objects vertically between different floors. So we have provided such solutions to IC packaging and testing, as well as wafer foundry operators. And also the loading requirements for PCB are much heavier, much higher than IC packaging and wafer foundry. So our smaller, so we can use another type of carrier, or it's a type of AGV to meet the customer's transport needs. For PCB, we primarily provide the tools for the front end and the back end applications of the customers. In addition to hardware upgrade, we also provide the customers' assistance to the customers so that the customers can have integrated software and hardware. For the PCB industry, relative to semiconductor and IC packaging, we need to make sure that the different tools can be network connected. Our definition of our operation is that our first engine of our growth is smart manufacturing. That is helping customers introduce Industry 4.0 and also conduct real-time monitoring and feedback from their production lines, and also optimizing the production, the different various communication linkage between the production facilities. And also, after you collect data, the purpose for collecting the data is to conduct predictive maintenance. Our second engine is focused on the transport of different parts or wafer parts for semiconductor operators. As of 2023, you can see that there are great demands for ABF carriers. And also TPCA Association has defined very important product roadmaps, such as high-speed computing, 5G related, and high-power solutions. So for the product development and also development of the carriers, they are conducted to meet the needs of the market. Due to the needs in these industries and also the needs for their production processes, we also provide different plans. We also have formulated different plans as to how we can make improvements to address the needs. Because SAA is focused on automated equipment, we pay special attention to the technical roadmaps or technical white papers introduced by the industry associations. Of course, we are not always very successful in implementing smart manufacturing, because sometimes the customers may have different ideas and different needs for smart manufacturing or for different solutions. So it's very difficult for you to just apply some systems to address the needs of all customers. Sometimes customization is very important. So we try to stick to the principle of 80-20. 80% of the solutions are shared and 20% may be adjusted to meet individual needs. In order to address the needs of the customers. And also, as Mr. Jian mentioned, we are also facing the war in Ukraine and all the trade war between China and the US. All these will affect the supply chains. Many companies are pulling out from China and they are moving back to Taiwan, or they move to Southeast Asian countries. So in the course of such change or migration, the companies cannot just rely on the conventional concept of creating facilities or designing the layout of their tools. Oftentimes, they need tools such as digital twins to conduct simulation and adjustment in advance, so that they can reduce the gap between the ideas and also the reality. And also the PCB production processes are very long processes. Our work is not concluded at the end of this. There may be different back and forth adjustment to various process steps.
And especially if you look at the mid-grade or high-grade PCBs, the manufacturers are also different. So the transparency and the various aspects are actually more important, because if any flaws occur during the process, then these products would not be able to be used and would be considered to would definitely considerably lower the yield rate. So in a factory layout, you would want to take into consideration these different ideas and concepts, and to understand what are the priorities. For the owner, what one wants is to seek the best return on all the costs invested. They calculate the ROA, the return on assets, and if the revenue does not offset the costs, then you'll definitely be hearing from the boss. So in this industry, oftentimes we hear people saying, so why do we need to move into smart manufacturing? Some companies think of smart manufacturing as just a trend. But we have to look at the basis. It's actually there to assist the company to increase its competitiveness and to increase the volume that can be manufactured. The PCB industry is considerably a more traditional industry compared to the testing facilities and the semiconductor fabs. So in terms of standardization and the interface unification, PCB manufacturers definitely face more obstacles, as the equipment used tend to be more traditional. But for a company that built its reputation being a PCB manufacturer, we actually have a keen understanding of the niches in this industry, and the end purpose, of course, to make sure that every penny invested is worth it. And that's how you get a happy boss. Here, I'd like to share what we often discuss in the manufacturing process: the receival of the raw material to the input in the production line up until the stage when the end product is created. The equipment and systems used in the entire line, of course, are dispersed and vast. But we need to first know which station should be prioritized, and to learn that, we'd have to understand the efficiency and the effectiveness of each workstation. Therefore, for our case, we usually suggest to clients that you need to first have a general picture of what you want to get from smart manufacturing. What is the end goal? What you expect to achieve through smart manufacturing. And by setting the goals in a step-by-step process, for example, a major threshold every 3 years and various smaller goals on an annual basis, the company would have a better idea of how it should proceed in the smart manufacturing transition. Clients have various requirements, not just for the OT, but they will likely want to move up to the MES along with the Internet of Things, and that would, of course, require additional suppliers and even consultants. And clients want a solve-all solution in order to reach their targets. They don't necessarily just want this piece of the puzzle, they want the entire picture. If we look deeper into smart manufacturing, you would see that it can be segmented into automation for the manufacturing process and automation for logistics. So what I would like to talk about now is actually the logistics side of smart manufacturing. Moving equipment or raw material used to be done by hand, but we are now seeing more and more companies using AGVs or automatic guided vehicles. The cost for AGVs as well as the system stability have also improved. They are less expensive nowadays and have higher quality. In the past, these AGVs had to follow a fixed line on the floor. They will basically be detecting the lines or wires on the floor. But oftentimes, these wires or lines might be rubbed off by the wheels. So it's not essentially the best solution to guide these AGVs. And nowadays, we're actually seeing new methods and new technology that would actually allow smooth operations of the AGVs. Of course, this all translates into cost, but as I have mentioned, it comes back to what do you care about? Do you want to remove the effects of the wheels rubbing off these lines on the floor? Or are you willing to invest in a new system that does not require the guided lines on the floor? Here I'd also like to share with you the RGV. This actually is a guided vehicles that move over the factory floor close to the ceiling. These rails are established high above, and the guided vehicles actually move above us. But for these rails, what you would need is a way to remove the dust that may accumulate. For example, when the guided vehicles move along the rails could accumulate dust and grit, and you need a way to remove the dust and grit so as to not affect the movement of the guided vehicles. And if we look at the big picture, logistics start from the movement of the raw material into the production line and how the end products actually reach the customer. For us, of course, this build-up depends on the customer's needs. Different customers may have different requirements, and the logistic plans would likely affect how the manufacturing process or production line works. If we look at a basic model, we would start from a general warehouse. And once the raw material enters the factory floor, if we use the PCB industry as an example, then the raw material actually goes through various workstations at the different floors. And you would need equipment to move the raw material or the half-finished products between the floors. And you would also need places to store the half-finished products, as there may be waiting times between the various workstations. So how this floor space is utilized and set up would definitely play an important role in the efficiency of the production line. You would also need to leave space for people to walk. In the past experience, oftentimes we see floor places leaving only a 1 meter width passage for people because 2/3 of the room is taken up by these half-finished products or storage space. And of course, the purpose is to speed up the production and to improve the quality. If we look at PCB manufacturing, for certain workstations, time is actually of the essence. if the process is not carried out quickly, the oxidation of the metal components might be so severe that quality is impacted. And therefore, not only is the entire flow a key issue, but also need to look at the speed of how these raw materials are moved along the production line. So these all translate into improving the efficiency and quality of the manufacturing process. This slide shows an example of a factory floor design. The customer would give us their requirements, let us know what they need, and then we would provide a sample like this. But of course, it still needs to be run in order to understand whether it's truly effective. For example, we may suggest installing 26 AGVs. But for the customer, they would of course start to think whether 26 AGVs may be too much, or maybe too many, or are 26 AGVs enough? So this actually would rely on further communication with the customer in order to truly understand what's the most cost-beneficial solution. And speaking of digital twins, we also talk about the interaction and interface between the physical and the virtual space. So how do we employ or utilize digital twins here? I would say digital twins actually is a way for us to speed up the testing process. In R&D, for example, we can use digital twins to speed up the testing phase and to create multiple simulations. In the PCB industry, we can build a model directly in the virtual space instead of drawing it out on paper as we did in the past. And this would actually create a virtual model for the customer, which makes it easier for them to visualize what the final layout would be like. Humans are visual-oriented creatures. And as you can see from this clip, having a 3D clip definitely works wonders compared with simply printing it out on paper. So if we look at this slide, you will see the above would be the traditional layout and how we plan the factory floor on paper. And the bottom would be the 3D model. A traditional 2D layout would only be able to give the averaged answer. It's difficult for us to consider the length, the speed, for example, how fast the conveyor belts are rotating. And it's also difficult for us to show the interactions between the different layouts. But with a digital model, we can clearly depict what is going on in the factory. And when there's a congestion, the digital model or the digital twin will just be able to show it very clearly. And that is something that the traditional paperwork finds difficult to depict. In terms of increasing the efficiency, digital twins also works wonders. If you look at these examples, the customer would always be taking the cost benefits into consideration. Therefore, they want to know what's the shortest route, what's the quickest way, and the most cost-effective way. And these can actually be quickly adjusted and test run in a digital twin model. This would include, for example, the utilization of the AGVs, utilization of the robotic arms, etc. These can all be shown in a digital model or a digital twin, and therefore through digital twins we can actually create a more straightforward and understandable model for the customers, and this would definitely speed up the discussions and negotiations between the customer and the service provider. I talked about how we use digital twins in a logistics environment, but we can also use this in a single case situation, for example, for a single robotic arm.
And we can make improvement at the design end. You do not wait until the physical products are created before you make any adjustment. And the last two pages, the last two slides deal with the elements that we need to address in creating logistic solutions or optimizing the logistic operation for the customers. In creating the PCB Metaverse, we need to consider all these factors as indicated on the slide. That is, we need to consider the ecology, and we need to also digitize. We need to apply IoT and intelligence operation so that we can create great value. That's why we have created the IS Asia Alliance to provide comprehensive solutions to the customers for their choice before they set up their facilities. That concludes my presentation. Thank you very much. Thank you, Mr. Liu. Now, Jiaming Chen is going to, Manager Jiaming Chen is going to present a token of appreciation to Mr. Liu. Thank you, Mr. Li, once again. Now we are going to take a break until 11 a.m. Mr. Li just mentioned that digital twins can be applied to different stages of production in our exhibition areas outside of the meeting room. You can visit different booths that demonstrate or showcase the applications of digital twins. And to the right in the exhibition area, there are students demonstrating the results of their research. And on the monitor outside, we will also play back the video clips relating to the various digital twin applications. And please come back to the meeting room at 11 a.m. sharp. And make sure that you put your lots to the box so that we are going to draw a lot later.
The mass flow conveyor is an essential addition to FlexSim's standard object library. This conveyor object can simulate the flow of high volumes of units. It will be useful in various modeling applications, including food and bulk goods manufacturing, bottling and packaging, and in other high-speed or high-volume manufacturing systems. The mass flow conveyor is unique in that it can model a conveying system transporting thousands of units with high accuracy, but it can do so without breaking the bank on computing requirements. How is it so efficient? The mass flow conveyor uses more of a fluid-based modeling approach rather than simulating each discrete unit. It would take a massive amount of resources to simulate thousands of bottles, cartons, or other small pieces individually. Instead, the mass flow conveyor calculates the unit density and maximum possible flow rate for the units traveling the conveyor, then tracks density changes resulting from other system changes. It's fast, it's easy to use, and the result is beautiful. FlexSim's rendering engine draws individual units based on the density at a given point, so you'll still get to see your production system in vivid detail. Check out the mass flow conveyor today. You can try it out free by going to www.flexsim.com.
Closer to you, closer to you. Yes.
Should be okay now.
Now it's left and it's connected. Yes.
Okay, you're free. Okay, we're done.
Okay. 大家好，我们是国立台中科技大学流通管理系的学生。那我们的主题是应用 Flexing 模拟前置仓物救人上架优化。指导教授是陈志腾博士。那参赛组员有我陈如萱、许玉文、李嘉文、龚诗英还有潘文琪。那我们的大纲主要分成绪论、文献回顾、结果与讨论3个部分。那第一个要讲前置仓的重要性。前置仓呢，就是可以距离消费者更近，可以达到快速配送的目的。那什么是前置仓呢？前置仓的英文叫做 Micro Fulfillment Centers， 简称 MFCS， 面积大约300到500平左右。那它是离消费者最近的中小型仓储配送中心，主要目的是完成快速配送。
接下来介绍问题描述。物品补货的前置作业中，进货到上架储存的时间基本上占了一大部分，且传统的 AGV 只有一种类型，就是负责将货物由进货区移动到分类区，再至上架储存区，也就是 AGV 未进行分工，导致效率低下。那本研究将以 AGV 分工为目标，缩短前置仓上架的时间，将进行 AGV 一类及二类的使用比较，并评估出二类 AGV 是否较有效率，以利解决前置仓上架的问题。下一页。再来是本组的研究目的，我们将探讨 AGV 2种类分工运作对上架效率的影响，还有比较2种类 AGV 是否较1种类 AGV 更有效率。
接着由我介绍研究方法与流程。那我们的第一步是拟定主题，比较1类 AGV 和2类 AGV 的进货及上架速度。第二步是设计平面配置图，确认模拟物件的摆设。接着使用 Flexing 模拟，透过模型可以模拟出运作速率的数据。接着依据数据得出结论，我们将撰写结论之后，针对未来可进一步延伸的研究方向提出建议。下一页。那这是我们的文献回顾，我们现在介绍的是前置仓上架效率，我们主要参考了这一本文献。我们发现，在仓库中上架作业占了总营运成本的50%到75%，占比非常的高。所以我们将进行模拟测试，查看分工后的 AGV 是否有改善上架效率，并降低营运成本。下一页。
那接下来由我介绍 AGV 的文献回顾。AGV 在未来趋势物救人中是扮演非常重要的角色。那 AGV 除了可以提高生产力并降低人力成本之外，还可以减少产品的损坏，也可以在高峰期迅速调整车辆的路径。下一页。那接下来是智慧物流相关模拟工具的文献回顾。我们发现市面上有很多种物流模拟软体，那我们最后选用的是 Flexing， 是因为它的操作界面直观易懂，而且流程视觉化，也可以依据正式情况摆放各式的物件。下一页。那这是我们 AGV 2种分工的示意图。我们将设置一台 AGV， 在分类好的货物将由剩下的 AGV 来上架。下一页。
这是一类 AGV， 也就是传统的 AGV， 如影片上所呈现的，3台 AGV 都会同时在分类区及上架区进行工作，导致货物会堵塞在分类区，造成效率不彰。下一页。那下面这一个影片是我们打算研究的2类 AGV， 会有一台专门在分类区进行分类的 AGV， 其余2台 AGV 在下区将货物上架。那可以看出上架区进货区的货物不会像传统的 AGV 需要等待上架区上架货物后才运送到分类区。下一页。这是我们的结果与讨论。那依照 Flexing 的模拟结果显示，传统1类 AGV 与2类 AGV 大约跑了2000秒后，会发现有分工的2类 AGV 运作数据较传统1类 AGV 高。那 AGV 的运作模式越高，越能提升整体进货的上架效率。下一页。我们的报告到这里结束，谢谢大家的聆听。
The mass flow conveyor is an essential addition to FlexSim's standard object library. This conveyor object can simulate the flow of high volumes of units. It will be useful in various modeling applications, including food and bulk goods manufacturing, bottling and packaging, and in other high-speed or high-volume manufacturing systems. The mass flow conveyor is unique in that it can model a conveying system transporting thousands of units with high accuracy, but it can do so without breaking the bank on computing requirements. How is it so efficient? The mass flow conveyor uses more of a fluid-based modeling approach rather than simulating each discrete unit. It would take a massive amount of resources to simulate thousands of bottles, cartons, or other small pieces individually. Instead, the mass flow conveyor calculates the unit density and maximum possible flow rate for the units traveling the conveyor, then tracks density changes resulting from other system changes. It's fast, it's easy to use, and the result is beautiful. FlexSim's rendering engine draws individual units based on the density at a given point, so you'll still get to see your production system in vivid detail. Check out the mass flow conveyor today. You can try it out free by going to www.flexsim.com.
活动即将开始，请大家赶快入座哦。活动在1分钟开始，请大家赶快入座。好，谢谢大家。
Thank you. I just noticed that a lot of you spend a lot of time in the students' model areas. If there's not enough time, maybe later you can use your free time to visit the booth. Now our conference is going to resume. Our next speaker is, we know that the Metaverse is a very important topic. It's a very hot topic. And we need to put together the efforts of our colleagues in different parts of the world. When we are not in a physical space location together, we can still collaborate. And then we can create different operating models. Now let's welcome Chien-bo, product manager of NVIDIA, to give us the next presentation. His topic is Metaverse and manufacturing Metaverse and NVIDIA's Omniverse. Let's welcome him. Good morning. My name is Chien-bo. I'm Roger. I'm a product manager of NVIDIA. First of all, I'd like to thank Mr. Jian, Pitotech, and also I'd like to thank Simwell for the invitation. In my presentation, I'm going to talk about the roles played by NVIDIA in the context of Metaverse. Is my voice okay? I'm very happy that so many of you have attended this event. Taiwan plays a very important role in the manufacturing sector in the world, and also the manufacturing sector is also facing great transformations. Whether we are migrating towards 2.0 or 3.0, we are facing challenges, and we are trying to accelerate our progress, and there are different elements: hardware, software, or solution-based accelerations. I think these are the major challenges that you are facing in your journey of transformation. Let me briefly introduce myself. I joined NVIDIA in 2012. You can see that I have grown a lot of gray hair. I don't know whether maybe I'm old enough to show that, but when I started to work at NVIDIA, I worked on consumer markets. And previously, I've worked in 2 or 3 other companies. While working at NVIDIA, my clients are mostly, my customers are mostly manufacturing and construction industries. And the video clip I'm going to show you was something created about 2 months ago. And this is a video we showed our customers regarding NVIDIA's deployment of its strategy or solution of Omniverse in the face of Metaverse. For different end customers, such as car automakers, media, construction business, or logistics service providers. 2 years ago, when we launched the video clip, before we launched the video clip, we had done a lot of homework and research, and also we had worked with software vendors such as Vaccine. Let me show you the video clip. Let me see if I can play back directly. How do I play back the video clip? Okay. The organizer, I believe, will provide the link, which will allow you to access the video clip. You are welcome to take a look. In the area of smart factory, BMW is probably the fastest mover. When it comes to digital twin, we engage in a lot of discussions with BMW. BMW is trying to resolve the issue that they were facing. They hope that they can simulate the process for the creation or the building of the cars before the cars are actually manufactured. And for example, when the engine is put together, there may be other interferences from other departments. Within BMW, at the stage of painting, as a result of the painting, the product needs to be put in a particular area for an area. And there are also other steps such as baking after painting. And there may be defects that may be created. So at that time, to address these issues, BMW worked with us and have a lot of discussions about digital twin. In the production line, through we take the newest model of the car. I believe that if I remember correctly, that was an iX series of electric car. Before the car was introduced, we worked with BMW for the creation of the model, and that was a new experience. And BMW felt that they had benefited a lot from the process. And actually, we have entered the phase of 2.0 in our collaboration with BMW, and this deals with a lot of discussions about the workflows and production processes. My understanding is that BMW is going to introduce self-guided vehicles, or AGVs. They will introduce AGVs in their smart, intelligent production lines. And they hope that through virtualization, they can simulate the directions or the routes for the operation of the AGVs within the facilities. This is a picture that just indicates the efforts I just say. They can use software to get the parameters of the processes, and also they can create some 3D models in advance. And through the Omniverse software, they can create a USD format at one time, and then through Vaccine, which creates a connector for NVIDIA, and we embed the connector. All the relevant 3D models can be incorporated into the intelligent software. As I just said, NVIDIA, let me first talk about the role played by NVIDIA in Metaverse. We are primarily provide GPU computing power. NVIDIA cannot create Metaverse solutions because there are way too many end customers of Metaverse. So we still focus our efforts on advanced chips and 3D computing power. For multimedia industry, WBP is a very high-profile advertising company. Actually, WPP has customers that are top 20 players in the world, but due to the pandemic, the impact of pandemic, they have come across a lot of hurdles and challenges because there are different country requirements for entry to different countries. So if you want to create, shoot your advertising films in particular countries, WPP tried to create an Omniverse platform in its studio in London, and the platform addresses the issue of traveling, and because traveling was not possible during the pandemic. So Omniverse can help address that. If the setting takes place in a glaciers environment, we can create a 3D environment like that in WPP's studio in London. And we need to use NVIDIA's 3D software to create, to set up the model in WPP's studio in London. NVIDIA, because of pandemic, a lot of face-to-face exchange is not possible. So face-to-face meetings are almost impossible. So we can only do so remotely. But our workflows should not be interrupted. So as a result of that, we need to do that remotely. So a lot of products are developed remotely. However, when you do that, there are different points of conflicts or difficulties. In the past, when you engage in physical development, maybe your partners are sitting next to your cubicles. You can have face-to-face and easy communication. But now, when you try to develop products, you have to do so through remote discussions. Like I said, a lot of software products are developed like this. Take BMW, for example. There are different functions such as painting, interior design, engine, surface treatment, and also QA. For these people, they need to use the vaccine, the entire sets of software packages. So many people should be allowed to participate in a remote meeting like this. NVIDIA plays the role of providing accurate computing power. So in the face of the era of Metaverse, we have proposed the solutions for 6 different industries. For self-guided vehicles or even scientific calculations, we have come up with our solutions based on our capability in computing power. For the construction industry, the collaboration of different parties is very important. There are some parties that work on the interior, some work on the electrical and engineering integration, some work on civil work, some work on interior design. For these parties, in the past, when a project is consigned and the designer or the architect create the drawings, and then the parties specializing in electrical and mechanical aspects will continue to participate, will then join the project after the drawings are created. For many construction companies are working very actively with NVIDIA out of the understanding that because of the rising labor cost, they cannot wait until the particular project is completed before they can launch another project. So there are a lot of new collaborative processes.
So, for example, when you're actually working on the foundation, they may already be building the steel structure. And in a traditional reinforced steel or reinforced concrete buildings, you actually no longer need to set up a foundation first. For the SRCs, they actually are able to carry out the foundation laying and the building construction all together. Then this actually saves half of the time. And the reason they're able to do this is through the 3D modeling process. And they will be able to understand which area can be constructed first and which area would not impact the construction of another area. So these are ways the 3D models can be used in the architectural world. And this has solved a lot of obstacles that they faced in the past. We've been working with the top 10 architects, and they have been utilizing new models and ways to utilize this technology. In the Metaverse or Omniverse, NVIDIA actually plays a rather straightforward role. What we aim for is to allow or create leaders like vaccine. We hope to help them speed up the daily processes and move these processes to the cloud or to a 3D platform. If we look at the current manufacturing industry, many companies are still accustomed to the step-by-step process type of concept, but this would definitely bring new obstacles in the future. If we look at, for example, TSMC or other leading companies, almost every leader is thinking about ways to increase efficiency and to shorten the time to market. Companies also wish to lower the probability of human error. Therefore, for NVIDIA, what we can do is we first look at the roles that different people play. For example, the RMs, the RDs, or the sales. And we want to create an identity for these people and understand how these identities can be represented in the cloud. If we look at our offerings, we have the Omniverse platform that's designed for the Metaverse. I would say it's not just a slogan or a fancy name, but rather by Omniverse, we wish to connect our platform to the various platforms in the world. We worked with Maxine in creating the 3D model of human portraits, and we use, for example, the Unreal Engine to do that. And therefore, we see ourselves playing an important role in many of these processes. The experts in this field, however, often ask us one question, and that is, so is Omniverse trying to replace, say, Maxine, for example? Well, this is actually recorded, so I can just say this publicly. NVIDIA has no intention of replacing these companies. NVIDIA wishes to provide a more transparent channel for the players to communicate with each other. If we look at the Maxine, for example, they may find it difficult to create 3D models. And for us, what we can do is we can import the data through the 3D engine into the Omniverse and then recreate it on the Maxine platform. So I can say this again, and that is NVIDIA has no intention of replacing the software developers. The software developers all have their expertise in the field, and NVIDIA has no intention of replacing the software developers. But we do wish to work with all the leaders in these various areas. For example, Delta, AUO, or Wisron, the developers definitely do not use just one system. They may use Maxine in the developing stage. Maybe they use Adobe Photoshop in creating the layouts. Actually, when you turn on your laptops or cell phones, it's very likely that you would use many different programs or apps at the same time. So what we are looking at is a way for users to utilize multiple platforms at the same time. And what NVIDIA wishes to do is to create a very straightforward 3D model to be used as an interface for users to use and interface with these various platforms. I myself have a R&D background, and I recall that in the early days, a situation I often encountered was that I used Cadence, and I had to output it to the mechanical engineers. But the mechanical engineers usually use PDC Quill. And the interface between the Cadence and PDC Quill is actually not that smooth. Therefore, when I was the R&D, and I was in the notebook design business, I actually had to talk to the mechanical engineers directly to let them know how the fluid dynamics are designed. Otherwise, if I output the models directly, they will not be able to open them up. Now, they will not understand how the models were designed. So a lot of the communications actually had to be resolved manually. And if the software actually were able to interface with each other smoothly, then a lot of this time can actually be saved. If I can actually input the Cadence format into a platform, and then that platform would generate it into a suitable format for another platform that the other engineer is using, then this would save a huge amount of time in the communication process. So we have a format transforming platform called Nucleus. We need to connect to Maxine to connect to the different platforms devised by the developers. So we're actually putting a lot of effort in make sure that this can happen. And one way we do that is to offer free development kits. Of course, NVIDIA is well known for rendering and for simulation, and we've actually put these all on the Omniverse platform. I talked about the format transition being a cornerstone in smoothening the communications. So what we did was we actually found a USD format that can solve, in a way, the issue. In the Omniverse, this means, of course, that we have a lot of connectors. I talked about how the input and output, or upload and downloads, have to occur quickly and in real time in order to save time. But from the R&D's perspective, this is something that they actually don't need to know. If you use, for example, the Omniverse platform, this is already in place. And you can focus on your own work, your design work, and you don't need to worry about whether the formats do not show up correctly, or whether the design is unable to be uploaded to another platform, etc. So here at NVIDIA, other than creating these connectors and interfaces, we've also created a user-friendly interface targeted at different roles. For example, the employees and the owner or the managers may require different interfaces. If we look at the different industries, be it in audio, in car manufacturing, they actually have different key points, indicators that they wish to follow. So these can actually all be incorporated and included in the platform. So we have the solutions for the various industries that utilize these 3D models. And if you're interested, I certainly encourage you to visit the NVIDIA's website. You'll be able to find a link there that you can put down your email, and we can share the link and share with you these free development tools so they have a better idea. Actually, I recall that when we're in the PCB when I was in the PC manufacturing business, heat was an issue, and that actually had to do with the thickness of the PCB. The thicker, the more likely that it would be affected by heat. And customers don't like thick PCBs because customers want thin models. So this is actually a dilemma. If the customer wants long-lasting, good-performing, and lightweight devices, but oftentimes you need to strike a balance. And when we get the experts from different fields, we actually may hear different opinions. For example, the mechanical engineers would say, no, this is the thinnest I can go. There's no way to go even thinner. And yet for other experts, they would say, but in my design, I actually need it to be at a certain thinness. And can't you just to take off another layer? So from this example, you'll be able to tell how important the communication is, especially when the various experts are brought into the same place. So finally, I'd like to talk about the Omniverse Enterprise. For this environment, we do have different packages that are offered by NVIDIA. Feel free to contact the organizer, and we will be more than pleased to share these package solutions with you regarding the different services such as Omniverse Nucleus, Omniverse Create, Omniverse Connectors, etc. So I talked about providing free development tools. You can simply click on the link here on that's shown on this slide, and you'll be able to download the Omniverse software. my suggestion would be to try out some functions. It's kind of like playing a video game. You would find that we have optimized many of the functions, and you might find that Omniverse actually helps you speed up your daily work progress. A lot of my clients tell me that the time-saving feature is very apparent. But of course, to use the Omniverse, you need to have a GPU. A CPU alone is not enough. And just remember, you need to have a GPU. So I think that's the end of my report. Thank you very much.
Thank you, Mr. Xi. Mr. Jian is going to present a token of appreciation to Mr. Xi. Thank you once again, Mr. Xi, for your sharing. Now the next speakers are from Innolux. Innolux has demonstrated its determination and achieved good results. FlexSim, what kind of benefits have FlexSim provided to Innolux? Let's welcome the speakers from Innolux to share with us the benefits they have enjoyed from FlexSim. The topic is the experts in the application of digital twin to the best solutions. I'd like to invite my colleagues to also come onto the stage. Good morning. Good morning. 11:30 is not a favorable time slot for me because you may be hungry. So I'm the only thing that stands between the presentation and lunch. I think there is a lot of value in the presentation I'm going to give to you. And I look forward to further discussions or exchanges with you. These are my colleagues. His name is Jin Qin and also Frank. They will also join me in presenting some slides to you. We are experts in the application of digital twin. You may not understand why I use this topic. I'm from Innolux. I don't need to introduce Innolux to you. All you need to know is that it's a very good company, and we have dedicated ourselves to digital transformation. We hope to. We are working with the various parties to make innovations, and our basic information and profile is available on the internet. To become an expert in providing the best solutions, my background is industrial engineering. I studied industrial engineering for 6 years, and I've been working in this area for over 20 years. Industrial engineering covers a lot of aspects. It includes logistics, warehousing, quality assurance, and CIM, MIS, etc. You can see that this is a very busy slide. You don't know that it covers so many aspects. I know that in the audience there are many professors and students of industrial engineering. In the past 2 decades, I'm a leader of an organization consisting of graduates with industrial engineering backgrounds. What value can industrial engineering bring? Like Mr. Chien mentioned, IE is not about cost down. IE is about creating value. But what's the value I'm going to create? I've been thinking about this question for a long time. When I was a freshman, when I just became a university student, when I entered the department office, I saw a woodpecker. I don't know whether this story is shared anymore by industrial engineering departments. I wonder if I visited to the wrong office. Why do I see a woodpecker? It's not a department of animal science. Why woodpecker? Because industrial engineering is about diagnosis for different facilities, companies or factories alike. We are just like doctors. We want to provide solutions. But how can I play the role of an industrial doctor or physician? I'm going to come to that later. But we can think about that for a moment. Now that we're talking about the role played by a doctor, so how do you know that you have a fever? My question to you is, how do you know that you are having a fever? I know that you don't want to mention that. The answer is is very simple. Use a thermometer. Use a thermometer and measure your temperature. You will know that you have a fever because it's over maybe 37.5 degrees Celsius. So a thermometer is very important. That can help you determine whether you are having a fever. But when it comes to the operation of a factory, how do you know that the factory has an issue? So we need visualization. We need to create sensors. We need to describe the problems. So after detecting that there is a fever, what do we do? Then the doctors will ask you a number of questions. And then to determine whether actually the fever is related to your ulcer or headache or maybe inflammation in other parts of your body. So it's called diagnosis. So it's knowledge systems engineering. But we need to accumulate knowledge in order to conduct such a diagnosis. But a factory is a very complex facility involving many different workflows. So how can you accumulate proper knowledge to provide an accurate diagnosis is a very important challenge. And a lot of aspects of a factory are interactive in nature. So sometimes you may determine that there are no correlations between different elements. But for these critical factors, how do you properly control these factors? I think this is a very important question. Only by controlling the critical factors can you achieve good performance. And as Mr. Chien mentioned, digital twin can help you do that in a positive way. So the topic is digital twin. How can it bring clean data? It can create a lot of data. When we accumulate big data, separation of digital is a very difficult field of study. I'm sure that you know. If you are in the background of industrial engineering, when it comes to data processing, this is a complex field. For digital twin and proper experimental design, we can separate different types of data. So this is a very important task to be performed for a digital factory. After we have identified the critical factors, and you also, when you want to reduce cycle time, reduce your inventory, the key is about how you can control these critical factors. So this is what I call a diagnosis. After that, you can make a prediction. What does prediction do? You can create different scenarios, and then you can conduct your analysis based on different scenarios. Just like going to a doctor. When the doctor determines that you have inflammation in your intestines, then the doctor would say, if you continue, what kind of treatment is recommended? If you don't want this treatment, what options do you have? And also the doctor will show you or tell you how you can recover your health, how you can take care of yourself. Our digital twin can also help us make a prediction. And also prescription. Prescription is a decision-making process. When you are a freshman or junior in university, you probably understand some other courses of industrial engineering, but it's not so simple in the industry. For prescription engineering, there are different ways to conduct the prescription. But this is a step that will help us optimize. For example, the algorithm currently being used by AlphaGo. So this is an example of an optimized algorithm, and we can apply such an algorithm to digital twin. We can achieve the prescription that I'm talking about. So that many of my colleagues are working on production management in IE. They may not have the background of IE, but we have to understand that IE is about creation of value. So what is a digital factory? I think the slide includes my definition of different concepts, and also some textbook information. A digital factory means a factory that is transformed from a physical factory by establishing models, and also the data should be output concurrently. And then, through digital twin and experimental design, and DOE to perform experimental design, and then simulate relevant factors, and to control the critical factors in order to achieve optimized operation. Can we use an actual factory to do this? Actually, the plant manager would not cooperate with you because a plant is not used for experiment. The plant is constructed to engage in production. So we need a tool like this so that we can fulfill the function of industrial physician. So I have shared with you my idea about the functions of the functionalities of a digital factory. Now I'd like to invite my colleague to introduce how a digital factory can be implemented. The topic is industrial metaverse. So I think we should begin with the factory. That is how we can use digital twins to realize digital factory in order to become an expert in the best solutions. So I think you have a better idea about my topic. Now I'd like to invite my colleague to continue with the presentation.
Okay, thank you. I would now like to share with you how Innolux builds up a digital factory. Let's look at this slide first. If we look at the actual factory, the build-up is actually a very complex process, as many factors come into play. We need to take into consideration the human factor, the mechanical factor, and the process factor, etc. If you simply copy the layout, there will definitely be issues that you cannot overcome. And the key here would, of course, be the people factor. Different people will definitely operate differently. And if we look at the factories here, there are actually a lot of variables that you need to take into consideration. So with that understanding in mind, how do we design such a factory's layout? In the past, we used physical models or drawings. If you want to compare the cost for two factories, you can simply add up all the expenses, and then you'll be able to know what went into the process. If you want to calculate the efficiency of two factories, you can simply check the output and divide it by time. But is this all to it? You actually need to understand what caused the factory to have such an output. And there may be many factors that come into play that cannot be shown on paper or via a physical model. Therefore, in terms of the production line management or the factory layout, the traditional method actually presents a lot of hindrance in the discussions and remodeling stage. Therefore, the best solution would be to use a 3D digital model. It may be difficult for us to explain how the process works to the boss, but if we can show the boss a video clip, then oftentimes that answers all his or her questions. So how do we build up such a model? The first step is usually to use the big data. So can we simply use the data from the factory? Well, as I've mentioned, the factory takes into consideration many factors, the human factor, the machine factor, process factor, etc. And the data collected directly from the floor shop is actually quite complex. It's not clean. So we can use big data on a single motor, a single machine, or single equipment. And this would be what I would call clean data that can actually be analyzed. But if we look at the entire factory, are you really sure that the readings you collected truly reflect the actual situation? Or might the readings actually be interfered, or the readings, or would the readings actually also contain some interferences? I recall one of my seniors saying that, well, if a client gives you a factory that costs 20 to 30 billion and asks you to redesign it, are you willing, or do you dare to build it all directly from in the physical world? I don't think so, because the cost of error would be too high. It is possible that maybe you can tell the client that, well, they can just trust me. But I don't think that's always an acceptable answer. When I was studying, we actually carried out these various types of model building. And oftentimes, when I thought this was the correct model, my professor would be able to change one of the variables and show that the model would not work in a certain situation. And then I had to start over again. Therefore, if it was built physically, it's not that easy to simply tear everything down and start from scratch. And that's why we need digital models. So other than the ease of adjusting the various factors and parameters, a video clip is also a great way to communicate your ideas to the boss. From my current work, this is what I mostly do. And if your computer or laptop has a fast processor, then this is actually this can be quickly done. And you can show this to the client or to the boss and save you hundreds of words. So how do we build a digital factory? Do we actually recreate each component digitally? Well, that's not the case, actually. Here we have the so-called hard limits or hard stops. For example, the exact time required for a certain process, the ratios. If we look back to the factors required, we need to take into consideration the variables, for example, the human factor, and of course the process factor. If we want to build a successful digital model for the factory, we definitely have to take the human factor and the process factor into consideration. We also have to look at the confidence level and the efficiency level. Perhaps it's possible for us to include all the soft and hard limits, but we then have to check the confidence level and the efficiency or effectiveness. That is, whether you're using actually the wrong solution to get the right results, or actually using the right solution, but you're getting wrong results. So we have to carry out the verification and the validation. For example, the mathematical models used might have errors within, and you'll need to check all the errors through check all the models through the verification and validation process. For example, is the output as expected? And since there are only 24 hours a day, if somehow the model generates results based on a 25-hour day, then that is definitely wrong. Therefore, these are all the minor errors that might occur in a digital model, and we can only eliminate them through careful checks. This is actually created through FlexSim. This is a sample. Actually, I'm not sure if I can play a video clip. Oh, we can play video clips. Hey, wait! I actually have. Let's try. Let's try to see if we can play the video. Well, I've actually removed the key information as this is the customer's trade secret, but this is an actual representation digitally of an existing factory, and you can see how the workstations are set up. And since I had to take out some of the more sensitive information, you would only be able to get an idea of what it looks like. But as you can see, as the factory is running, all the performance indicators are shown directly on the dashboard on the right. In the traditional method, if you want to get these numbers, you'd have to take perhaps a long walk around the factory, which may be 1 to 2 hours. But with this model in place, the numbers and values are collected in real time and shown directly on the dashboard. So next, I also like to invite another colleague to talk deeper on how to use digital twins in this work. Okay, thank you. I'm Frank. Actually, I will be taking over from now. So once we have the digital model in place, how do we actually use it? Well, we have to look at the purpose for having such a digital model. I've listed here the 4 major or most commonly seen problems that factories face. The first is production lines interfering with each other. Second would be changes in demand that would affect the production line management. The third would be how a lack of product types would actually affect production. And finally, how we evaluate the performance of the various workstations. So the owner or the manager will have to look at these questions from these different perspectives. That is, what exactly is the current performance's bottleneck? This would likely be answered by looking at how the production lines interact or interfere with each other. And the next perspective would be to look at how cycle time is affected. For example, would a different allocation change the cycle time? And then a third would be if we switch the production types or the prototypes, will we be able to improve the overall performance and efficiency? And the fourth would be what exactly is the impact of the hardware's setup and allocations? We can actually test run the various layouts to come up with the best layout and the most effective layout for the factory. If we look at the right, we also carry out performance evaluations. And in the past, we used Excels and had to input the values manually. But now, through a digital model, you can immediately adjust the values and get an optimized solution quickly. If we look at the first perspective, that is, what kind of bottlenecks exist? In the model, what we can do is we can make these adjustments and value changes to understand how the production lines interfere with each other. So we can first create a simulation of the productivity. A here would denote the difference between the current productivity and the optimal productivity. So once I am able to learn the reasons for interference or which production lines are causing the productivity to go down, then I can next make the switch or allocation change in order to improve this. Okay, this appears to be a simple slide, but as I've mentioned, we actually need to have a model first, and then at least 20 to 30 design steps in order to check the validity and verify the model. would likely require at least 4 to 5 computers running the model at the same time. And only through these repeated tests would we be able to get the actual productivity and the difference between the production lines. The gap shown here might be small, but for a large-scale factory, a 1% difference will likely translate into hundreds of millions of dollars. And if you can simply make a 1% improvement, this will likely create a huge revenue upside for the company. So this may appear to be a very simple graph, but it actually requires a lot of effort to generate. And to protect, of course, the identity and confidentiality of the client, I'm forced to remove the more sensitive information.
Now I'm going to give you the second example. This is one of the cases that we have handled. It's relating to assessment of equipment. At that time, we use FlexSim to perform the simulation. This model may appear very simple, but it has a lot of parameters. For example, the AGV sloping operation, and also there are different many parameters. In the past, for the calculation of a particular solution, you need to spend a lot of time. Now, by using FlexSim, you can finish the calculation very quickly, and also the validation or the verification through FlexSim can help us identify the appropriate solutions. So I can consider my experimental design to assess if the tool improvement achieve our original purposes. And also, I can simulate the changes to the performance of the tools. For example, the number of crashes or the longer time that is taken, and how that affects our productivity, and to what extent a bottleneck is created. That will help us make a forecast on the direction of our investment. This is also a real case study, just simplified. At that time, the engineers spent about over 2 days. After the models were created, in a few seconds we can see the results. We are not just looking at one scenario. There are about 20 or 30 scenarios, and we can identify the best scenario. Now I'm going to move on to share with you our journey of digital transformation. In public information, I'm sure there are a lot of things you can have already known, but I can share with you our experience. For students and professors or our participants from companies alike, I like to use the word sharing. I think I'm sharing my experience with my friends. In the implementation of digital transformation, I'm sure, like many companies, you will face the issue of support from IT people. And sometimes IT people cannot provide timely support. Without online support, you cannot achieve digital transformation. So at that time, when I was thinking really hard about a solution, a colleague approached me at that time. He said that I have a suggestion to you. He said that I can train some programmers because for IE people, we know programming. So at that time, we designed some basic systems programming courses, such as Java, etc. But when we offer the training, the problem is that nobody signed up for the training. I couldn't understand. I spent money out of my own pocket training myself to do programming. How come nobody wanted to participate? And then I realized that even though people were eager to be trained, but they have already been very busy. They just didn't have enough time to do this. So and then I came across another colleague in the pantry area. So I think it's a good idea to sometimes walk around that area, maybe come across colleagues with ideas. And I was approached by another colleague. He mentioned that there is a concept of RPA. He's from RPA. He's a systems engineer working on RPA. In the field of IE, RPA is about improving the process that will help reduce our loading. So RPA is just like an assistant that can help reduce the loading. So we can introduce an RPA. As you can see here, there are many different projects and also tasks involving the training of people. So IE field is a very complex. It can, just like many other fields. For example, in the medical science, there is precision medicine. A common issue that we are facing is how we can train engineers, IE engineers, with know-how in digital factory. Digital factory is not a new organization. I'm talking about this as a concept, and our people should develop their knowledge about digital factories. And not just the knowledge, they need to have hands-on experience. So you need to achieve that so that you can successfully achieve digital transformation. There's another important aspect of digital transformation. So when you have the people who are available, who have the time to participate, I think we need to consider that aspect as well. We need to consider the availability of the engineers. So we need to have a digital twin, which is very important. We have two coaches. One is Jin-Chin, the other is Zhongyu, the two of my colleagues who just gave the presentation. And Jin-Chin told me that that's the reason why he was invited to be an instructor or a coach. He said that he tried to accumulate his experience so that he can pass on the experience to other people. And many process-related systems are completed under the leadership of him. And also another colleague believes that if the right tools are used, we will be able to realize the value and quantify the value that we realize. And also through digital twin, we can implement the entire concept of digital factory. And this is the last slide I'm going to show you. I'd like to welcome you to join Innolux. There are many students and professors here. And also, our human resource people are also seated in the back and eating. Our HR people. I'm sorry. There's another, and also Ting Jie. They are both from our HR. So if you are interested in joining the company, feel free to talk to them. particularly those who know how to use FlexSim. There was a teacher who approached me about the opportunity of internship. I said that FlexSim is a good opportunity. It's a good starting point. We welcome people who know how to build models to join us. And also we can work with schools to jointly realize the ideal of digital factories. We have established a number of digital factories. We have dozens of factories to be established. So you are more than welcome to participate in the collaboration. Particularly, I think we also welcome interns. I believe that you have practicum courses in senior years. We can work together to create digital factories through digital twin so that we can become an expert in digital transformation. And also we can help Taiwan achieve digital transformation. More importantly, you can create value for yourself and also for Taiwan. Thank you very much. Thank you, Mr. Liu, Mr. Chen. Now, President of Symwell is going to present a token of appreciation to the presenters.
请留步。那我们现在要进。
Now we are going to take a group picture of all the speakers. Now I'd like to invite all the speakers to come to the front. Masks.
谢谢讲师。
Thank you. Please be seated. Now we have another group photo of all the participants again. For those of you who have a sign before you, please raise your signs, and then our photographer will take a picture of us. What?
好，后面学生可以站起来啊，就比较后面的那边。
For people sitting in the back, you can probably stand up so that we can capture you in the pictures.
后面有挡到的往这边靠哦，后面有挡到的往这边靠。
好，来我们一起喊工业元宇宙。
Industrial Metaverse, great. On 3. Let me check if everybody is in the picture. 3, 2, 1. Industrial Metaverse. Great. One more time. Industrial Metaverse. Great. Okay. Thank you very much. Now it's the lunch time. Our lunch break will be end at 1:20. We offer lunch boxes, and please have your lunch boxes in the room. Please refrain from talking to each other while eating, and also during the lunch break, you're welcome to visit the exhibition areas outside to look at the products of the students. And please scan the QR code in the back of your badge. You will obtain information about Flexim programs and courses.
哇塞！
外面的人都进来了。欢迎大家回到。
Welcome back to Flexim Future 2022. We also have a plethora of great speakers for the afternoon session, and they'll be sharing with us how they have used Flexim in their workplace. We'd now like to invite Manager Chien Rong-fu from Mirle. Mirle has been established for 30 years, and they started by the production line layout business using the traditional method, but they soon transited into a 3D model and the new flexing tool. So I'm sure we'd like to learn about why they have stuck to the Flexim system. And now let's welcome Manager Zhao. CEO Jian, Mr. Dai, distinguished guests, ladies and gentlemen, I am Chien Rong-fu from Mirle. Well, it was originally my superior who was scheduled to speak here, but due to certain reasons, he is unavailable today, and therefore I have the pleasure of meeting all of you today here. So I will be sharing, introducing the products and services of a company, and also be sharing our experience in previous cases. So I look forward to having further exchanges with all of you. First off, I'll be going over a brief introduction of the Mirle Group, and then I'll be sharing more information on the smart automation system, how the smart automation system can be implemented, what are the first steps that need to be taken, and finally I'll be sharing previous cases and cooperations that we had with customers. Mirle has been established in 1989. The chairperson is Dr. Sun. He's also one of the elite researchers at ITRI. And Mirle has been established for over 30 years, as you can see here. Well, the main reason for using Flexim is actually in the past, if we use a traditional method to organize the layout, then it is actually difficult to fully showcase all the factors on site, and it is difficult to show all the key areas in its full picture. So I will be, and when we came upon Flexim, we realized that this was actually a great tool to describe the layout to customers. Here I have prepared a video clip for all of you. That this will also be shown at the automation exhibition next week. So all the equipment shown in this clip were manufactured by Mirle. As you can see, the headquarters is in Hsinchu, Taiwan, and we have offices in Germany as well. And the focus of the company is on smart automation and how it can improve our livelihood. We can assist corporates and companies in making the digital transition. Helping companies utilize smart logistics systems. And we have worked with numerous well-known parties and companies. This is an introductory video clip of Mirle Group. And if you're interested, we'll actually be showing more information in the automation exhibition next week. Next, I'd like to share with you some of the latest clientele. If we look at the semiconductor industry, we worked with TSMC, SE Technology, Micron, etc. Also worked with car manufacturers in building the electronic equipment for electric vehicles, the Qualcomm, Continental. And for logistics, this is actually a new business line for us. We work with PC Home, which is a large online e-commerce system, Family Mart, Carry Logistics, etc. The next topic I'd like to touch on would be a bit more technical, and I will try to be as brief and clear-cut as possible, as people tend to get sleepy in the afternoon. So without further ado, when it comes to smart solutions in Industry 4.0, for the software side, we have WMS, MES, WES, etc. And these actually are all services that we provide. In the recent years, people are more interested in big data and AI, and therefore, Mirle has also created services in the big data and war room. And in terms of simulation, we mean simulation in, for example, fluid dynamics, logistics, electronics, etc. And today I will be focusing on logistics. For Mirle, I think we started in 2010, and the cooperation with Pitotech started that year, so we have at least over 10 years of experience.
Among panel and semiconductor customers, as you can see, a list of hardware equipment. This is a drawing that shows that that shows the transport equipment that is used in the production, such as OHCV, lifter, across different floors, and OHT is also quite commonly seen. And OHB, which is storage buffer. so that you can transport materials more quickly and you can reduce the idle time. We have actual use cases for these products in various facilities. Now let's talk about software. If you look at the green box, these are the software, the common software items of the company. And this is also the software for equipment control. And if customers need MES, we also have corresponding vendors to work with the customers. This slide depicts companies in the logistic industry or e-commerce industry. This is a traditional ASRS. We have worked on such products, traditional products, for over 30 years. And crane or shuttle, also there are different shuttles carrying different pallets. For e-commerce customers, they need to react very quickly. They need to collect orders and then fulfill the orders for the customers very quickly. In our simulation, we will conduct simulations to show the customers how many boxes are needed to fulfill how many orders. And we also have a turnkey solution. Regarding new logistic software and also panels and also semiconductor companies have different needs. And we have different controllers for different products. Regarding the linkage of these products, you can see that we have also set up proper linkages. And this is a control layer. There it collects data such as electricity consumed, torque, vibration, temperature. We collect this type of data, and we have introduced this in various facilities. Take, for example, predictive maintenance or diagnosis of abnormalities. They can be achieved this way. Now, I'd like to share how we conduct the planning when we introduce an automated system. In the beginning, we interview the customers, trying to understand their needs and expectation of the services that can be delivered by the automated equipment. And then we will conduct assessment before a report is issued. Up until this time, we conduct calculation and sometimes come up with 3D animations. And then we will use the data to conduct dynamic flexing simulation, which will generate a lot of detailed data. And then the e-commerce operator will know how much time is needed from the receipt of an order to the fulfillment of the order. For an automated transport equipment, in the actual production, you may have batch-related equipment. Automation is different from manual operation. So in that situation, we will recommend that a proper buffer be established, or the routes have to be changed so that the amount of transportation can be achieved. So after that is done, we will create a business plan along with a quote before the plan is executed. After the plan is executed, we also offer war room solutions so that we can tell if the plan is consistent with the outcome. Because simulation cannot capture all the aspects, we need to provide feedback to modify the models so that the models can better match what actually happens. I just introduced the way we conduct our planning for smart factories or for e-commerce customers. We would first assess the design condition, for example, the specification of the facilities or constraints of the customer's facilities. And this will affect the storage space design and the zoning of different storage areas. For e-commerce operators, they have different grades of product, and the storage of the products will affect the shipment of the products. So we can help the customers conduct assessment at this stage, and then based on the results of our assessment, we can conduct a simulation of the overall system. So we can conduct a full factory FlexSim simulation, and then we can effectively identify the bottlenecks of the equipment. And for a particular area, we may divide it into 6 areas. And first, we can then address the most critical bottlenecks by making local modifications before a larger model is put together. I think that's an advantage of FlexSim because it's quite convenient for FlexSim to divide the objects and integrate different objects. And then we'll help the customers calculate the manpower requirements. Or we can conduct ROI calculation or analysis, or the kind of saving that the customers can achieve with the equipment. Now I'd like to share with you some case studies regarding digital twin. I primarily would show the case studies through video clips so that it's more interesting to you. Now, this case involves a semiconductor packaging company. Another case is about a new logistic company. Now, let me talk about this company which engages in the packaging, semiconductor packaging. This is a packaging facility, and it has a lot of equipment and also a lot of process steps. This facility primarily uses OHT for linkage. So without static calculation, it's very difficult to identify the system bottlenecks. First of all, we would ask the customers to provide information regarding the input of the products. And then there are different output. And also in the course of simulation, we can ascertain the status of local storage. And this indicates that the storage space is saturated. What is interesting is that at the end of the simulation, different process equipment will have different utilization percentage. And through our dynamic simulation, we can tell that some tools cannot achieve the originally expected capacity. Some may be attributed to the characteristics of the tools themselves, but this kind of information cannot be provided on time. So to address this issue, we need to modify the models and apply the modified model to further simulations. Or we can reduce, or we can relocate the space for Stalker to OHB, or there may be more interference in OHT interbay. So we need to come up with shortcuts so that the operation can be smoother. This is the this is an animation of the actual operation. As you can see that this is our company's OHT. It picks up the material and then you upload the materials. And these are the pictures of the actual facilities of the company. So at the end of the simulation, we help the customer make adjustments to achieve their capacity requirements. And this is also about a semiconductor packaging company. In addition to Stalker and OHT, it also has AGV. And they are prone to interferences with so many different types of equipment. And then also bottlenecks can have a great impact on the capacity. For material handling, this is also true. AGV is walking on the floor and it cannot move too fast. Even though OHT may be fast enough, however, through AGV, it will take longer. So how do we address this issue? So we have spent a lot of time studying this matter. What should be noted is that we spent about 10 days in simulation, and the materials are input to an empty production line, and then we can observe the output of various process equipment, and then we can estimate whether the static parameters are the same as what we expect. You can see the status of equipment utilization or capacity utilization. I need to redact certain information because it involves customers' confidential information. And this is the capacity utilization of Stalker and also the capacity utilization of OHT. So if you only use AGV, the utilization rate tend to be higher. So we need to make some equipment change or adjustment so that the transportation speed can be enhanced. So you can see that the utilization information can be shown dynamically on the screen. In the course of the simulation, you can see some the equipment that has high utilization rate. The orange means that the machine is now being maintained or switching between different production lines, and the red indicates that the machines are functioning normally. Now this is about the substrate, semiconductor substrate, and this is the customer will provide the general layout requirements. And we can identify the yellow portion, which is a potential bottleneck. And we should try to reduce the distance between equipment or machines to save time. And you can see some additional information and also the results of the simulation.
The main purpose here is to see how the various OGTs can actually improve efficiency as the numbers go up. Because as you can see, the utilization rate would definitely go down in this case. But as OGTs are also automated devices, the more you have, the less efficient they are as they would interfere with each other. There is actually what we call an optimal equilibrium, and that is how, and we use FlexSim to calculate the optimal equilibrium. This is also a shuttle system that we have introduced. This would allow the company to move goods out of the warehouse very quickly, and the rate is currently at 5,000 boxes per hour. In terms of logistics, this is very fast. here we have a digital twins plan, but currently this is still being devised. For digital twins, the company's view is that we need to connect the actual needs at the factory floor with the linkages and instructions on the digital side. For example, if we are looking at a EV company, if the car has not been built yet, how do we assure the connection between the digital twin and the actual product? The model here seems simple, but this is actually a demonstration site that we have created. What we are doing here is we use the instructions given in the digital end to control the FlexSim model, and we hope to engage in this process before the beginning of every case so that we can have a better understanding beforehand and to give the customer a better idea of how our project or the FlexSim model would help them in setting up the correct layout. And as I've mentioned, we would have a automation exhibition next week. We're actually at booth M606, and I look forward to seeing you there too. Okay, thank you very much, Manager Zhao. I would like to ask our organizer to present a word of thanks. Again, we'd like to thank Manager Zhao. Next, we would like to welcome Vice Manager Hsu Chien-bo from Wisron NeWeb Corporation. Ms. Wang has numerous experience in IE and in the upgrade of production efficiency, and she has always said IE is like the doctor of a factory. So after utilizing FlexSim, she was able to give an overall picture to the clients and allow the factory doctors to not just look at just one aspect, but at the entire factory layout. So let's now welcome Vice Manager Wang to share with us how WNC uses AGV and the digital twin. Okay, thank you. I'd like to share with you a case, and this was actually entered as in a contest, and this was a model that was developed by my colleague. So I'd like to share with you how FlexSim is used, and it focuses on the AGV simulation and how the routes are planned. This would actually be an RA1 plant. I'll be going over the background for the simulation, the logistics, how the AGV's best routes are calculated, and the FlexSim simulation. We'll also be sharing our views and feedback regarding using the software itself. In terms of the background, at WNC, we have the dip at the front end and then the AGV at the back. So in the first step, we would first issue instruction to the electronic warehouse, and the material would then send to the dip line. After it's completed, it will then end up at the half-finished product warehouse, and then it goes to the next stage. The AGVs are utilized in moving the raw materials and the half-finished products. Therefore, multiple AGVs are required in this process. This is the first floor, and here we have the second floor and the third floor. Well, in the past, the industrial engineering colleagues used to use Excel to do the calculations. We would be inputting the values into the Excel spreadsheet and use this to calculate the personnel needed to move the material. For example, here you can see that we need 10 people to move this batch of goods from the first floor to the third floor. But with the FlexSim tool, we're able to not just verify whether the numbers are correct, but actually help us optimize the combination. And based on the actual layout, we can actually carry out a simulation. This is a static simulation in a way. So the prerequisites or hypotheses are, if we do not consider shift changes, it's working 24 hours a day, and we also do not consider possible AGV breakdowns, what would be the optimal route? So what our colleagues did was to create this model for the first, second, and third floor. The goods would actually move through this elevator shaft, which means that the AGVs will actually be traveling from the first floor to the second floor and the third floor as well. We also used the process flow in calculating the optimal route. So for the SMT requirements, in the past, in Excel, the calculation showed that we need 4.6 people. But for FlexSim, the simulation showed that we only need 4.09 people. As for the ATP side, in Excel, the calculation was 10.17 human power needed, but in FlexSim it was 0.66. So this actually gave us a better idea of what is the actually optimal number. And on the other hand, FlexSim can be used to check the answers, if I may put it that way. So for the SMT and the ATP on the back end, we found that the personnel requirement was actually similar to the results calculated by FlexSim. That is, when compared with the results we calculated using the Excel spreadsheet. Here we see another simulation on the first, second, and third floor with elevators connecting the floors. As for the ATP's raw material and the SMT half-finished products, this is the results of the FlexSim model regarding the AGV route. So in the past, the required number of AGVs was 9 and the utilization rate is 66. But in FlexSim, we only needed 8 AGVs and the utilization rate could actually go up to 70%. In a dynamic simulation, we can actually clearly see how the system would work in the real world. Of course, lowering the AGV count by 1 would be a significant cut on costs. Next, in terms of our experience using FlexSim, we actually started out using not FlexSim but Visual Component. But the Visual Component was targeted more for the mechanical engineers. Therefore, for industrial engineers, we found it a bit difficult to use. But now with FlexSim, my colleagues that have used both Visual Component and the FlexSim have reported that FlexSim is very user-friendly. And that was the most often heard comment. Of course, if you need more detailed simulations, you might need some programming. But compared to the other software that we've also used, we actually all prefer FlexSim. And as we have seen the 2022 FlexSim contest, I think there was an entry by the Taichung Technology University, and then the project was rather impressive. Well, I myself graduated from that school as well, and I think this contestant is also here, so I wish him or her good luck. Okay. Any questions for Vice Manager Wang? If not, then let's thank her again. And would now like to invite CEO Chien to offer a plaque of thanks to Vice Manager Wang. Once again, I'd like to thank Vice Manager Wang again. Now, with environmental protection being in the headlines, ESG is a key indicator for almost every company in the world. Can we use digital twins in ESG? It is our pleasure to invite Director Jiazhuo Huang from SimWeb Inc. to share with us how ESG can be utilized in digital twins and the metaverse, and how it helps reduce carbon emissions. Okay, so good afternoon, distinguished guests, ladies and gentlemen. I'm from SimWeb Inc., and it will be my pleasure to share with you how digital twins can be used in ESG and carbon reduction. Well, ESG actually covers many aspects, and I would like to start off by giving a brief introduction to ESG. Basically, if we look at the terms, it covers environmental, social, and governance. Basically, ESG covers these three aspects. We often talk about the environmental side. This would be environmental protection, reducing the negative impacts of climate change, green production, etc. For social, this covers, for example, HR, product responsibility, and labor relations, as well as risk management. And for governance, this actually covers the work ethics, corporate governance, competition, and supply chain management, etc.
With respect to the environmental aspect of ESG, we talk about the issues of climate change. We hope that by reducing the carbon footprint of products, we can reduce climate change. So, by using digital twin, we can reduce our product carbon footprint. And also, we can maximize the land utilization efficiency. Regarding the reduction of carbon footprint, we can address this issue from the aspect of design. That's why we specifically cover aspects such as design and manufacture. Actually, there are different interconnected elements that we need to consider. In Taiwan, land utilization is a big challenge because Taiwan is a small island. We have very limited land resources. 20 years ago, when we helped Zhonghua auto manufacturer in planning their production lines, the production lines overseas, because of spacious facilities, one production line can be as long as 3 kilometers, but this cannot be seen in Taiwan. So with limited land resources, how can we better utilize the land resources so that we can preserve our trees and forests while maintaining the quality of our life? I think this is a very important focus we should bear in mind. In terms of the social aspect of ESG, we need to consider how we can properly design the work of the employees so that their workload can be properly distributed and reduced. And also, we need to engage in effective communications between different departments to save the time and energy of the employees. And ultimately, we need to look at the bottom line of the companies. We need to identify the best investment and profitability models so that we can achieve the best results. Now, let me talk about the benefit of using digital twins in ESG. We can use digital twin for product design. Let me give you an example. About 30 years ago, or even when I was a college student, that was about 1992 or 1993. The design was done originally by hand drawing of drawings. You create drawings by hand, then you use CAD, AutoCAD, and create two-dimensional drawings, and then we switched to three-dimensional drawings. In 1999, in addition to 3D, we need to also include the element of virtual reality. Why? Because we need to communicate with relevant collaborators. In order to communicate a particular drawing, my ideas may be different from the ideas of different people, because different people have different perspectives. So communication may be a challenge. So why do we need a three-dimensional rendition or presentation of a drawing? Because we hope that all the issues can be properly addressed through seamless communication. Why do we need 4D? Because we hope that we can also present we can gain a dynamic understanding of the behavior. So CAE means that we can gain additional perspective on top of 3D, so that when I design the product, I can choose the right materials, and also the design approach is correct. This is an automobile, for example, a car, Mercedes-Benz. It has 38 speakers. Where should I install them? Who knows? How do you install the speakers? How do you achieve the best design? So we use CAE as a tool to help us design the best position or location of the speakers to achieve the best effect. And also, people nowadays are focusing on electrical vehicles. And Tesla is very good in implementing very complex applications in a simple way. But when you put a lot of things together, heat dissipation becomes an issue. Without using the tools, you can only rely on your imagination. But when there are issues, it's very difficult for you to communicate whether you have the right heat dissipation solutions or the selection of materials. And also the choice of motors, the rotation speed, whether it's fast enough. So through digital twins or CAE, the purpose is to reduce your try and error in your design so that you can reduce the waste in test production. Let me give you an example. After I have produce the motor, and then I need to conduct the testing. Assuming that traditionally I would need to spend 1 million NT without CAE, but if it's not successful, do I need to create a new tooling? Probably we did. We need to do that for a tooling. When you create a tooling, if anything goes wrong, you need to change the tooling, and then you need to you spend a tooling. It can be very expensive, and the material cost is very high if you have to recreate the tooling. And also for a tooling that is not reworked, but instead it's modified, the tooling may not be durable. So when you want to create a product, you need to spend a lot of time testing the production to identify the proper parameters of for the production. So you need to spend a lot of time in try and error, and also you need to dedicate a lot of materials and manpower to the trial process. So all these we have to take into account. So we hope that we can use a CAE to reduce production waste and reduce trials. And also we can reduce communication issues by communicating, by presenting the issues clearly. So I don't need to actually create a prototype before conducting further experiment. Even though you have created an issue-free prototype, you still need to conduct test production. And you may need to try this 2 or 3 times. So in order to reduce your waste in materials, you should try to reduce this as much as possible. And also, when it comes to the material selection, you can choose the proper materials or reusable or recycled materials. And also, you can optimize the design and enhance your product quality so that you become more competitive. And also, we can reduce the frequency of prototyping. So that means that by using the digital twin, you can achieve all these. You can create. You can also extend the life cycle of the product. In terms of production planning, the digital twins can help you optimize your plant layout and reduce the land area that is used. That is, you can minimize the use of land while creating the facility that you need. And then you can optimize your production capacity and your labor requirement. Some customers have come across this issue when they want to assign workers to certain tasks. They need to solve the issue of when the materials will arrive and how many people should be assigned to handle the materials, and whether there's enough time for certain steps. And also, you can engage in production and transportation with proper quantities of resources. Let me give you an example. For AGV, I can estimate the operation maybe based on maybe 50 AGVs. Maybe as a result of simulation, I don't need 50. All I need is maybe 40 AGVs. In other words, I can analyze, conduct analysis to come up with a proper number of equipment that I need to achieve my goal. And also, based on the number of orders, you can determine how many machines should be turned on and operate. In the course of production, sometimes some machines may be defective or may have failed, and they need to be maintained or repaired. So you need to consider how many machines are required, because there may be differences in terms of the number of machines that should be turned on, depending on the situation or the requirements of the order. Sometimes maybe you just turn on 9 machines, but the process step may run into a problem. But you may need to activate a particular particular machine in advance to warm up, and in order to assume the part of the operation, or because some other machines may not be able to maintain the workload. And if there may be a delay if you don't do that, and that will affect the utilization rate. So you can determine the machines that you should put into use. And for some operation, maybe you have different chillers. The number of chillers should be considered. So when I conduct the data analysis to help customers, a common problem is that when the chiller is in operation, when the automated mode is switched on, but when 7 chillers are in operation, but 3 suddenly shut down. We know that when the machine is turned on, the power consumption peaked, and this may have a negative impact on the factory, because the utility, because the peak power consumption may exceed the contract power consumption, and the factory may be penalized by the utility operator. So I think this issue can be addressed by way of simulation. And then you can determine how many chillers or compressors or boilers should be activated. We know that chillers, compressors, and boilers are all power-hungry machines. So if you can do a good job in calculating the number of machines that are used, you can save. This will contribute greatly to your energy saving. And also, you can use this tool to analyze bottlenecks. And ultimately, all these elements, these considerations will affect the ultimate power consumption. Virtualization fitting is also is often used when you are designing machines. When you design machines, if there may be interferences, basically all I can do is I cannot identify the issue until I actually try to run the machines. And after the measurement is conducted, I need to modify the design, and it will need to spend a lot of time in the process. And after the machines are put together, and you need to run it again and see if there are any problems. If there are still problems, you need to disassemble the machines and make adjustments. So if there are multiple impact points, what do you do? And also another issue is waste materials. If something is too short and you cannot be achieved, and you may need to trim the material, and the old material will have to put back to the inventory. And you need to have an extra storage for the inappropriate or unusable waste.
And if you store it for a long time, it might even rust or start to erode. On the other hand, this would also allow us to increase the communication efficiency between different departments, because this actually shortens the CT and allows the machine to be online quicker and to lower the maintenance period. You'd also be able to save the time and electricity spent by utilizing a digital twin. So the best part of this is we're actually offering the customer one production line, and we actually sent one of our best engineers, because the engineer was there to adjust the actual machines. And the person spent 1 year, but there was nothing else he could do because basically it was a trial and error process. When we got this project, we used simulations to test the system, and the simulations actually found the optimal allocation. So if they started to use simulations earlier, they didn't need to assign one engineer to work on this problem for 1 year. So this would definitely be a time-saving and personnel-saving solution. The simulation allows us to have a better understanding of how the processes would work without having to actually recreate it in the real world. The simulation also does not require any use of raw material and can basically be carried out indefinite number of times. Next, we have the offline programming issue. A problem that one of the customers encountered was during the automation phase. After it's completed, they had a personnel issue. That is, the setup actually requires people to make the adjustments manually. Although the robotics arms were already installed, the company actually needed people to spend a lot of time to do the necessary adjustments. And the adjustments actually took over 1 month to get the robotic arm to move exactly as planned. But with offline programming, we actually don't need to have a person to be there on site. Not only does this save human power, but it also saves energy, as the adjustments actually mean that you're using the robotic arm, but it's actually not working for you. So with offline programming, you can test the movements in the virtual space first to check if the movements are the ones you want. This is especially important when there are multiple production lines, as a virtual simulation would be able to check if the lines interfere with each other and if the efficiency can be set at an optimal level. Changing production lines and adjusting the production lines actually used to be two different lines of work. The engineers are going to spend a couple of months doing the adjustments, and once the production lines change, then this would have to repeat itself. But if we're able to carry out offline programming, then this can all be done in a virtual environment, and the programs will be directly copied to robotic arms. Next, in terms of AI, we believe that it's also part of a digital twin. Well, some don't understand why we consider AI to be a digital twin as well, because when people think of AI, they think of a decision, an automatic decision making program. Well, in simulations, we usually use it to tackle the more complicated or complex issues. But in AI, if we use it in ESG, we actually would have like an additional assistant to carry out the simulations for us. And therefore, this speeds up the simulation process. At the initial stages, you might not see any connection with ESG, but with the simulation speeding up, for example, in the past, when we ran the AI-powered models, it would take perhaps maybe 45 days on a 586 computer. But if you use the current computers, perhaps it's the simulations can all be done in one day. CAE, for example, also takes a long time to calculate in the computer. But if you really want to make the process more efficient, for example, in either lab tests or multiple simulations, then utilizing an AI to carry out smart simulations would be a solution. That is, the AI would be able to slowly converge the results to get the optimal balance instead of simply rerunning the simulation hundreds of times. And in this case, once it's targeted at our various questions, you would be able to save time and reduce waste. The process itself would allow the manager to optimize the entire process. And since the end result can be obtained faster, there would be less downtime at the factory. On the other hand, we'd also be able to have an early warning system as to when the machines are about to break down. But of course, this is another dilemma. Do you want to switch out the components before it breaks down, or do you want to fix it after it breaks down? For example, when we look at car maintenance, we carry out frequent car maintenances because we don't want it to break down, say, on the highway. We do not want to have to fix it after it breaks down because that could cause additional problem. But on the other hand, we don't want to carry out maintenance too often. So reaching an optimal equilibrium is actually very important here. The point is, how do we make sure that we make the best use of each maintenance? That is, we lower the trips to maintenance as much as possible, yet make sure that we get as much uptime as possible. So this calculation can be done with the assistance of AI in these simulations. Another thing that I like to share is when the machines break down, there's always a reason. The traditional method is to carry out periodic maintenance to check the performance of each machine and make sure that they meet the requirements. But it's done periodically, and there may be times when it simply breaks down at an inconvenient time. So with this the AI in place, we'll be able to carry out more dynamic maintenance. Another area that this can be utilized is in FlexSim, they actually have an enhanced learning model that is able to improve itself. For example, in the AGV, we talked about how to calculate the optimum number of AGVs that should be used. But on the other hand, we may also need to set some limitations for the AGVs. For example, we need to set no-enter zones for the AGVs or zones in which certain actions cannot be done. And if these rules are violated, it's possible that the AGV would get stuck somewhere, and that would actually cause the system to come to a halt. We also don't want the AGV to, say, run out of juice in mid-route, as this would actually also cause problems. So, as I've mentioned, the purpose is to try to minimize the number of maintenance and yet maximize the amount of uptime. without having to fix the equipment after it breaks down. AI can also help us analyze the reasons for the breakdown, and this can actually be turned into a control factor. And of course, it helps us lower the simulation runs that we need. Next, in terms of FlexSim on ESG, here we see the three major aspects of ESG: for environmental, social, and governance. FlexSim actually is able to assist in these areas listed on the slide. For example, for the environment aspect, in terms of the state-time analytical chart, the re-layout, multiple floor, source and transportation, or what-if scenarios, combine separators to reduce waste, and utilization analysis. This would also be used in reducing waste. So for in the environmental aspect, FlexSim can be used to reduce the carbon footprint, to maximize the land usage ratio, to optimize the usage of raw material, and finally to reduce waste. We are able to get the numbers beforehand. In the utilization analysis, not only can we analyze how it's best utilized, but it can also be used to reduce downtime. In terms of the social aspect, FlexSim can be used in HR management and interpersonal communications. For example, in terms of the personnel allocation, we have a VR function in FlexSim, and this can be used in communication and in understanding the best location. In terms of the process flow, for example, if, say, an employee A is promoted, then his original position would be taken by one of his previous colleagues or subordinates. And the process flow would actually show the best career route and how the company is currently using its personnel. This can also be shown on the dashboard for better communications. And finally, in terms of governance, FlexSim actually can improve the revenue through the financial analysis and financial data that can be generated through these calculations. So if we look at the environmental side, we can use FlexSim to decide, for example, how many floors is needed, how the layout is best done. Do we need to have a fast lane in addition to the normal lane for AGVs? And how should the travel routes on the multiple floors be designed? So the area that is in the red square would be the areas most often used. And okay.
If a product is done and the product has to wait for the AGV, that's wasted time. And sometimes the AGV may be waiting for the product. So the best scenario is that the AGV arrives just in time to pick up the products. Now, regarding the design of the scenario for the input of materials, then we can decide the scenario which is more favorable to me, more applicable to me. And also regarding, I can conduct what if scenarios to consider the different deployment scenarios. I may not need so many separators. because I don't have so many stalkers. And then if you have additional separators, you may need to find a place to store your combiners and separators. So if I can reduce the use of my resources, if I can optimize my equipment, and then I can also adjust the number of machines that are turned on. And also, I can include my electricity bills as part of our calculation. Regarding the social aspect of ESG, we can conduct the state and utilization analysis of the personnel. And then we can conduct our analysis to determine how many people should be assigned. And also, the workload should be appropriate. So actually, the handling of manpower is the most difficult because people are not machines. They are not robots. I cannot expect them to work at their 100% capacity. So maybe we should consider maybe 85 or 86% or even 88% capacity. But if you want to push it any harder, the employees may suffer too much. So we need to consider the work assignment and the distribution. And also through VR display, we can engage in communication. And also in terms of process flow, we can create a drawing to demonstrate the process flow. And then with that, I can more effectively communicate. And the people who will hand over the work can better understand what is expected to be done. So with visualized reports, I can understand the status of different machines, and then I can conduct my analysis to see the capacity differences between the machines. FlexSim can also help us consider ROI as well. For power consumption, it can also include power consumption as a parameter for analysis. And this is a case study involving AGV AMR. One issue is encountered in the course of a calculation. In the past, a calculation was done manually. But what is the issue? You spend a lot of time in the calculation. But if you need to remove a particular machine, you don't know where to put the machine. If you have too many AGVs, the route may be congested, just like traffic congestion. The more AGVs you have, the more challenging it is for you to manage the fleet of AGVs. And you need to have the control of different intersections. So there may be a lot of issues relating to AMR. You need to control the intersections. Even if you have tried to optimize, but there may be issues that emerge randomly, and you need to adjust your dispatch assignments. And also the AGV slow down when they sense that there are people around. And this will also affect the efficiency of AGVs. So if there are too many AGVs or AMRs, it will end up wasting electricity and resources. But if you have very few AGMR or AGVs, there will be a lot of wait time spent. So for AMR, I need to consider the rules that should be implemented. This involves the push style vehicles, and something has to get out of the way before the vehicle can proceed. So maybe we should design some overpassing routes or obstacle avoidance rules. We can also include the power consumption in our considerations. And then we can analyze the utilization rate of AGVs to determine how many AGVs I need. And also the charging efficiency and also the recharging level or charging efficiency. The more AGVs you have, the better you can capture the problems that you will come across. And then this kind of information will be quite effective and useful in helping you resolve the issues that you come across. Now, regarding the test run of AGVs, in the past, you had to do coding and to control the entire physical plant. Now, we hope that our central control system can virtually verify the operation of AGVs. And after that is done, I can then arrange or design the routes that can help us the time in handling the AGVs. And we can reduce our waste in time and resources. So we can verify the logic and the routes ahead of time. And after your verification, then you can dispatch the AGVs to reduce the time, the waste in time and resources. Now, for AMR, first of all, we need to consider that there are two objectives for production line optimization. First is that you don't cause any delay, and the second is you need to reduce traffic density in the production facilities. The ultimate goal is to prevent the shutdown of production. And some routes are shared by people and AMR. In this case, they tested different algorithms and under different scenarios. And also they analyzed based on 7,500 missions. And as a result of analysis, they determined that all they need to do is to have 40 AGVs. So as a result of that, you can identify the most appropriate or the optimal number of AGVs. You may need 40 instead of 58. And then you don't need to spend the time spending purchasing additional AGVs or additional materials or testing. That concludes my presentation. I don't know if you have any questions. Thank you, Mr. Huang, for your presentation. Now, please hold up your signs. There are two QR codes. The first is our QR code. We organize flexing courses regularly. In September, we are going to offer basic flexing training courses. If you are interested, you can sign up. The other QR code is a questionnaire for today's event. Please take your time filling out the questionnaires so that we will be able to organize the activities better in the future. Now we are going to take a break until 3:20 p.m. Likewise, feel free to visit the different exhibition areas outside. And also, we are going to have a lucky draw. Make sure that you put your tickets into the box.
我们的活动在1分钟过后就要开始喽，请大家尽快入座。 请尽快入座，我们的活动要。
Please return to your seats. We will be beginning in a few minutes.
欢迎大家回来。
Right, welcome back to the Flexim Future 2020 Forum. We will be welcoming the last speaker. When we purchase notebooks or laptops, we always think of what kind of performance do we need. In Flexim can actually be used in cloud computing to calculate the most optimal solution without actually recreating the situation in real time. And with Flexim, the simulations can be carried out anywhere, any place, and get the results from the cloud computing, and thus bring us into the industrial metaverse. Therefore, let's now welcome Project Manager Zhengbang Chen from SymWeb Inc. to share with us how cloud computing can optimize digital twins in a metaverse environment. So good afternoon, everyone. This is the last session for the forum today. I'll be sharing with you how cloud computing plays a role in the industrial metaverse. So I'll be starting off light and begin by sharing why I chose this topic. When we were calculating, for example, efficiency and optimization, we would like to know how it's done and, of course, the purpose of doing so. With cloud computing, we'd actually have a new tool to speed up all the processing. From my perspective, be it an industrial engineer, a mechanical engineer, or engineering in any field, engineers share one trait, and that is engineers have a lot of perseverance. When engineers are required on a production line, they need perseverance and patience to solve the issues or problems that they were called in the first place. But this also means that engineers need to spend a lot of time on the front line and at their production lines. There are engineers who are in charge of optimizing the layout, and engineers that are tasked with training the robotic arms. But in these training, sometimes the engineer is required to do repetitive actions. And in order to train the robotic arm to carry out delicate work, the engineers may need to lower the speed significantly and actually repeat the motions many times in order to get the correct movement. Another headache that engineers may have is in debugging. For anyone who has debugged now, this picture actually depicts perfectly what often happens, or what engineers who are debugging are like. So for the forum today, we actually see a lot of students who submitted their projects in Flexim, and I'm sure you've also encountered situations like this, in which you're trying to find out where the bug is, but it's simply so elusive. But worry not, because you'll have an opportunity to encounter situations like this many times if you choose to become an engineer. And some engineers actually work in CAE simulations, and some of these simulations may take days or even more to get a result. So from the CAD's perspective, you might be wondering, why do some models actually require so much time, whereas some can be run quicker? Let's look at this slide. I think you've played the game Find the Difference before, right? Can you look at these two models and tell me where's the difference? These are two CAD models. Can you tell me where's the difference? Let me show you the next slide. I think you would see the CAD model on the upper right has taken on a slightly different shape. So if we look at the 3D model itself, or the polygon model itself, these 3D models are generated from polygon mesh. And therefore, the 3D models, since they utilize the polygon mesh, the more triangles used, the more delicate the models are, but at the same time, the more computing power needed, not just to process, but also to render it. And therefore, the more polygons, the higher the requirement for computing power. And you might actually need one of the top-end graphic cards from NVIDIA to render the 3D models. So if we go back to this slide, the model on the lower left is the original CAD file. It has about 259,000 grids. But if we look at the upper right model, it actually has only 10% of the grid numbers, yet from a distance you cannot tell the difference. The only party that would feel the difference would be your computer. That is, the grids used in the upper right actually is just 1/10 that of the one on the lower left, which means the computer only needs 1/10 of its computing power compared with that used to render the lower left model. On the other hand, if you reduce it to just 2%, then the model is starting to look a bit different, and the distinction will become more visible. So with this basic understanding in mind, let's go back to how the models are generated. We have listed here 4 CAD models that have varying grids and in the polygon mesh. But at first glance, it may be difficult for you to tell the difference, right? As I've mentioned, the difference is not visually apparent, but it's significantly felt in terms of computing power needed. If you're able to reduce the number of grids to just 2%, then that means you only need 2% of its original computing power to render the 3D model. We have only 4 cars here on this model. If you have, say, 40 cars in the model, then the power saving is actually exponential. And you would definitely feel the difference when you run the model.
So whether you are creating a software CAD file or you are conducting a big data analysis, or the software, to a great extent, can be simplified so that unnecessary details can be ignored. Meanwhile, we also expect that streamlined or simplified models are still acceptable as a result of the computer calculation. We still achieve our purpose. They don't have to be an exact replica. All they need to do is they look similar. That should be fine. Now, let me talk about the techniques that we use to simplify flexing models. We not only can simplify 3D CAD files, we can also reduce the number of objects in the model. For example, you may need to dedicate input maybe hundreds of thousands of orders at the same time. We may not need to input such a large number. Maybe all we need to do is to input the materials that we need to produce in the beginning, and for the others, we can reserve them in a particular table. So we can reduce the number of objects, and also we can reduce the number of events. As you may know, FlexSim is an event-based simulation. So when you use the tool, if you have too many events, you will increase the workload of your CPUs. So events is an item that can be reduced. And also my SQL server for the database systems, they are used for queries of forms. FlexSim also have allows SQL queries, and we can optimize the queries in a more efficient way, so that we can search the contents of the tables more efficiently. And also, in some scenarios, we may need to create algorithms or process flows to define the dispatch logic in the production lines. In that situation, we may consider the use of AI to replace the algorithms to achieve the result of improved calculation efficiency. So of all the techniques, for the simplification techniques, the third is the most important. That is the reduction of events. In handling a model, if you trigger too many events, it's very easy for you to be unable to accelerate the processing of the model. And if you want to simulate a period of time, such as half a year or a year, you will end up spending more time for the calculation. FlexSim also provides some tools to help us identify the performance bottlenecks. The first is Performance Profiler. This is one of the tools provided by FlexSim, through which you can understand to what extent your model has a lot to be desired in terms of optimization. And the tool is advantageous to us. That is, if you click on a particular entry, it will show you under what object or what parameter or what tool causes the poor calculation performance. The second tool is Event List or Event Log, provided by FlexSim. This tool is used to address the issue of the event count. If you adjust the simulation to the maximum performance or to the maximum extent, you can use this tool to debug your model to see if they have any redundant events, or if there is a surge of events that are created in the form. Maybe you can change the way you create the model based on the information by identifying irrelevant or redundant events. And by doing so, we can greatly improve our simulation performance. Now, regarding the use of AI, let me briefly introduce to you how FlexSim can leverage AI for simulation and what are the steps involved when AI is used. Let me introduce the tools. The tool is structured like this. Flexim is like a training environment, so that the AI can learn freely in this environment, and AI can learn how to make the best decisions in the production lines. And this is our AI development workflow. There are 3 steps. The first step is training, AI training. Like I said, in the course of training, AI will be trained in Flexim to determine or to learn how the utilization rate can be enhanced by what steps. And then after training, I need to conduct validation. I need to determine whether the AI is overtrained or AI overlearned. I need to know whether the AI can only handle certain tasks. We need to avoid that. And for the third step, we can deploy the AI to the actual production lines. And as a result of the deployment, originally AI was used for virtual production lines, but now we can directly deploy the AI to the actual production lines so that AI can make actual decisions in an actual production line. Now let me talk about the structure. So like I said, we use Python to create the algorithm for AI. The first thing we need to do is to define the environment handler, so that a Flexim-based learning environment can be created, and the digital simulation is driven by Python. And then AI can observe the occurrences of the things that are happening to the simulated environment, and then Flexim will conduct relevant acts. For example, a particular material should be delivered to a particular tool, and after that step is performed, within the model, we can conduct our calculation to determine whether a particular step as such results in enhanced utilization rate or productivity. And then Flexim will tell AI that you have done a good job, I will give you a reward. What you have done is correct. And through this kind of reinforcement and learning, AI will automatically learn about the right thing to do to help the production lines. If the action just performed conversely results in poor efficiency of the production line, the Flexim will also tell the AI that the step or the action was incorrect, and AI can avoid the same action next time. And after that, we can proceed to the second step, which is validation. This is the reversal of what we discussed in the beginning. Previously, Python drives Flexim, but this time around it's reversed. Flexim will drive Python. Flexim will call the trained AI for the critical points, and by informing AI the current status of the production line, how many materials, what are the machines that are being used for processing. And AI is the trained black box, and then AI will do its thing. And as a result, our production capacity may increase or decrease as a result of that. And then I can tell if the trained AI is a qualified AI. So for the last step, I am ready to deploy the AI. And then the flexing can be replaced by the physical production line, and the operating steps are the same. In the actual production line, you need to make certain production decisions, and the decisions can be sent to the black box, AI-based black box, and AI will conduct actions to instruct the production lines as to what should be done. So this is a reinforced learning process for AI to improve the efficiency of the production lines. I talk about the techniques to simplify the simulation. Is there any other ways to help us optimize the calculation performance? The answer is the use of cloud computing. Using cloud computing can help us distribute some calculation tasks to different computers for concurrent or simultaneous calculation. When AI knows that we have more of computers available, we will be able to leverage more computing power. Now, this slide tells us how FlexSim can achieve cloud computing. In this architecture, there are two types of equipment. The first is a master computer. The master computer is used to determine how to assign the calculation test. And the slave computers to the right are responsible for performing the calculations. In terms of the operating steps, we need to launch our flexing on the master computer, and then the computer should be connected to the slave nodes or slave computers through the cloud. And then the models to be simulated or the jobs to be executed by the slaves are distributed to each of the slave computers. And the simulation is run in the background, so we will not see the process of simulation. And when the simulation is done, the simulation results are deleted and they are not kept on the slave computers, and the results will be sent back to the master computer. And then I can compare the different scenarios on the master computer to determine which scenario is the best. And the communication is done through HTTP, and flexing web server is used for the transmission. So through such a cloud computing technology, we can further expand it to AWS system. This is an Amazon's cloud computer, or Google's GCP, or Microsoft's Azure. For these platforms or cloud platforms can be used to set up the same system. So on the AWS cloud platform, we can create our EC2 instances.
And the instances will be used to serve as the master for FlexSim. Some instances are used for the slave function, and these can all be set on the router on the cloud platform and connected to the external internet. Our personal computer would then be able to connect to the AWS and carry out the simulations on the cloud platform. So to give a quick cloud computing test sample, so let's say we want to get the optimal number of workstations in this case. So for this model, basically we have set 3 different types of workstations, the P1, P2, and P3. And in the table below, you would see the possible number of P1s, P2s, and P3s. For example, for P1, we can have a minimum of 0, but we need to have at least 1 P2 and 1 P3. For this case, the unique part is it's not the more the merrier, because if there are too many workstations here, the logistics would actually be negatively impacted. Therefore, the purpose for this model is to get the optimal number of P1, P2, and P3s. If you've taken math classes on different combinations before, you would know that it would actually take a lot of time to go through all the possible combinations. For a single core computer, you need at least 30 minutes to get the optimal number. But for cloud computing, it would take much less time, and it could be less than 10 minutes. So what happens is we are running the simulations on the central computer that's on the cloud. And you don't need a high-powered device to access this central computer. Even a cell phone, for example, or a smartphone would be able to serve as the interface. So as long as your device is able to connect to the web, you can connect using a tablet or a smartphone. And as long as it has a browser, you'll be able to carry out the simulations on the central computer. For example, you can click the model that you need here on the interface, and then you can click the link that takes you to the page showing the model. And what you can see here is that you actually don't need to install software on your device to see the 3D model, as the models are actually all generated on the cloud. You simply need to use your device as a viewer, and you can see the utilization rate, for example, or the performance of the system. And you can actually adjust the dashboard on the right. For example, the number of AGVs or the number of warehouses. And this can actually be done on your device. For example, if you're talking with a customer, the customer might wonder what would happen if you, say, increase the number of AGVs. With this platform, you can simply show it to the customer and increase the number of AGVs. The customer can even do it himself or herself, as long as they know how to adjust the numbers on the right. So it's very user-friendly. And as mentioned before, the models are rendered on the cloud. So it's a very quick way to show this to your customers. For us, we aim to not just develop local software, but to bring the software to the cloud so that it's easier for users to utilize these models. All right, so thank you very much, Manager Chen. Okay, all the presenters have completed